به نقعا فوسطن به جمعا إن الإنسان لربه لكنود وإنه على ذلك لشهيد وإنه لحب الخير لشديد أفلا يعلم إذا بعثر ما في القبور وحصل ما في الصدور إن ربهم بهم يومئذ لخبير صدق الله العظيم.
Jazakallah. IoT is the technology that helps us to shape our lives, while artificial intelligence takes us to the next level. Artificial intelligence has the potential for the outstanding development of IoT. The combination of IoT and AI will lead us to a future where everything is connected and works smart. It is a promising future where more devices will connect. AIoT is becoming accessible. It is gradually changing the way we transform the fundamental way of living life and dealing with data in our daily lives. Now, I would like to introduce our guest speaker, Dr. Muhammad Shuja Islam, who is joining us from Saudi Arabia. Dr. Shuja is working as an assistant professor in College of Computer Science and Information Technology in Faisal University, Kingdom of Saudi Arabia. He did his PhD from University of Science and Technology of China. His research interests are distributed processing, face recognition, image color analysis, image matching, real-time system, software prototype, software quality, and visual database. Now I would like to request Dr. Shuja Islam to please start the online session on signal, image, and video processing. So you can share your screen.
Assalamu alaikum.
Yes, sir, you can start.
Yes, I can start. Okay. My name is M. Shuja Islam Sameem, and I'm working in College of Computer Science and Information Technology in King Faisal University, Kingdom of Saudi Arabia. And it's being an honor to be part of first international workshop on application of artificial intelligence and IoT. First of all, we will briefly talk about my education. I have completed my PhD from University of Science and Technology of China. It's top 100, one of the top 100 universities across the globe. I have completed my Master, MPhil and MSc from Electronics Department of Quaid-e-Azam University, where before this I have done Bachelor of Science with double math physics from University of Punjab. These are my few publications as a first author, where I have publications in expert system with application, applied intelligence, IET image processing, signal image and video processing, neural processing data, multimedia tools and applications, and also a conference publication. I also have experience of publishing one research patent. The name is shown here. And these are my few publications as a co-author. Now, a little bit information about my job expenses. Currently, I'm working as assistant professor in College of Computer Science and Information Technology, King Faisal University, Kingdom of Saudi Arabia. And before working here, I worked almost a year. I work as a lecturer in School of Information and Computer Science, Anhui Agriculture University. Before this, I was working as a research assistant from the university where I have completed my completed my PhD. Before, I also work in Pakistan in these organizations. Today, my presentation content are explanation of digital signal, image, and video processing. As maybe many people will talk about these things, so I didn't focus a lot in these two things. I try to be more focused on the research paper writing for these students, because I think so these things are very important for all of you, for all these young future scientists who are sitting here. First of all, we just briefly check out a digital signal, digital image, and what is a digital video. Digital signal is a signal that represents data as a sequence of discrete value. And this is a constant from the analog signal to a digital signal. It can be a binary form or it can be, but if it is a digital signal, it must be in the digitalized value. It can't be in the analog form. Simple digital signal represent information in discrete band of analog level. All level within a band of value represent the same information state. In most digital circuit, the signal can have two possible valid values. It can be either be 1 or can be a 0, or it can be true or false. If you want to study about this digital signal, there is a field which is called as a digital signal processing, where we have a digital signal. It is representation of a physical signal that is sampled and quantized. If you have any analog signal, we have to make it digitalized by using this figure. In the end of the slide, we can see that for each value or each instant value, we are amplituding it or we are quantizing it. And for each value, we are taking these values, and instead of using that analog value, we will use these digital values. As all the modern computers are digital computers, so they can't process the analog values. So we convert this, we do this conversion so that we can process this data. I mean, if the information is in 2D domain, it is called as a digital image processing. It is called as an image, and the processing is called as a digital image processing. Is cause of a digital computer to process digital information through an algorithm. As a subcategory or field of digital signal processing, digital image processing has many advantages over the analog image processing. It allows much wider range of algorithms to be applied to the input data and can avoid problems such as the build-up noise and distortion during the processing. Sometimes this happens that when we convert an analog image to a digital image, a part of information, we are losing that part of information. But sometimes this happens that we get less noise, because if we are taking less data, then less noise is coming to our systems. But yes, this is a trade-off between the information and a trade-off between information and about this conversion, so that we can do it for the processing. In the real world, there is nothing like a video which exists in the world. There is nothing a video, but these are consecutive frames or consecutive photos. If they are 24 frame per second, then we can say that it is a video or it is a film. But there is nothing thing which exists is a video. This is a sequence of the image. They are moving, so that we assume that something is moving. So but In real, it is a collection of the image. So if you want to do on video processing, it's same like that image processing, where you have to see or where you have to work on every different frame. In electronics engineering, video processing is a particular case of a signal processing, in particular image processing, which often imply video filters and where the input and output signals are video files or video streams. And video is an electronic medium for the recording, copying, playback, broadcast, and display of the moving visual media. Video was first developed for mechanical television systems, which were quickly replaced by the CRT systems and these things. And now then flat panels display like these things. Okay. Now I also want to talk about a very important domain, which is a machine learning. Many researchers in this era are working on the machine learnings, and the people are getting good results in all the fields where they are working. So for these young scientists, it's very important to know about the machine learning. They must be able to use these codes and to use important these codes and to make them for their own research utilized by them. Machine learning is a branch of artificial intelligence. Use compute-based system to make sense out of a data, which can be by extracting patterns, by fitting data to function, or classifying of the data. Machine learning systems can learn and improve. Yes, the more they are learning, the more they are improving. But there is again also a trade-off between the overtraining and less training. Bridges theoretical computer science and real noise data, where these are the few applications where many important industries are using machine learning to get more better results. Where machine learning is of two different types, which is supervised and unsupervised learning. Unsupervised learning is that there are not predefined and known set of outcomes. Look for hidden patterns and relationships and relations in the data. A typical example is a clustering. Okay, clustering is something like we have a cluster of stars, like the things which are related to together, or they are appear to be in a same domain. Then we have a supervised learning. For every example in the data, there is always a predefined outcome models the relationship between a set of descriptive features and a target, where we have two groups of problems which can be solved by using classification and regression. Classification: predict which class is given a sample of the data. If we have two numbers, 4 or 5, so we can differentiate it that which number is more near to the 6. But if we have a collection of information, or we have a large collection of the data, so that we can't simply say that this value is more closer to that, or that value is more closer to that. So for that things, we perform these two things, which are classification and regressions. And this classification matrix, you can see in the right side, a colorful one. It's a example of it's very better way to represent the data. Machine learning as a process where we have define objectives, where we have data preparation, and we have to model a building. You have to choose your models, that which models are you want to work with it, and which model is better for your data. Yes, these all things are not fixed. They vary from conditions to conditions, depend upon the data, your data. So you have to choose that which model is better for your data means. Then we have model evaluation and model development. And this is all in a circle. And this is a learning process. Machine learning as a process where we have data preparation needed for several reasons. Some models have strict data requirements, scale of the data point, and interval. Some characteristics of data may impact dramatically on the model performance. Where we have some raw data, then we can transform this data and then this data is ready to use. Yes, this happens when we are working on any real-time system. So first we have to do processing of our data to remove the noise and to remove the things which are unnecessary for us. Feature engineering is a backbone of any computer vision system. So the more better features you have extracted, the more better will be your results. So determine the predictor to be used in one of the most critical questions. Some times we need to add predictors. So you can use filters. Sometimes we need filters. Filters are used for same things to process our data, to remove the things which are unnecessary. So if you are working on any computer vision based systems, features are very important, that which features you want to take and which feature you want to remove or you don't want to choose. So feature selection is very important. And so here we talk about the model building. Here we have data split, allocate data to different tasks. We have to define training, validation, and test set, feature selection, and then we have to estimate the performance, and then in last we have to do evaluation and the model selection. I also want to talk about the handcraft features in this modern era. In these from last 5 or 6 years, there is a huge development in the field of machine learning and deep learning based algorithms. But there is also one thing which is called as handcraft features. Handcraft features are very important, and handcraft features sometimes they show more better result as compared to deep learning based systems. And they are extracted by using the edges and corners and can be based on any algorithms. They can be quantized, rotation invariant, covariance, or local binary patterns. So these all type of the features which are based on edges, corners, some locally binary patterns and globally varying patterns. These are terms and as the handcraft features. And there are still a lot of good results can be accomplished by using handcraft features. Now, everybody know about the research. So a primary purpose of the research is for documentation, discovery, interpretation, R&D, anything. So I also want to talk about the research paper. A research paper is a piece of academic writing that provides an
Thank you
access.
so much.
Okay.
With the shortage of time. Thank you so much, sir.
Okay.
Now I would like to introduce keynote speaker, Professor Dr. Suhail Asgar. Professor Dr. Suhail Asgar is currently working as a professor of computer science and principal investigator of medical imaging and diagnostic lab under National Center for Artificial Intelligence at ComSat University, Islamabad, Pakistan. Now I would like to introduce the keynote speaker, Professor Dr. Suhail Asgar. Professor Dr. Suhail is currently working as a professor of computer science and principal investigator of medical imaging and diagnostic lab under National Center for Artificial Intelligence at ComSat University, Islamabad, Pakistan. Professor Dr. Suhail is a member of the Australian Computer Society and IEEE. Professor Dr. Suhail is in the editorial team of a reputed scientific journal. He has also served as the program committee member of numerous international conferences and regular speaker at international conference, seminars, and workshops. I would like to request Professor Dr. Suhail Asif to please start the online session on artificial intelligence for healthcare. So you can share your screen. Can you hear me? Welcome, sir. So you can share your screen. Screen is visible now.
Hello, Assalamu alaikum.
Walaikum salam.
Hello, Assalamu alaikum. Hello, आवाज आ रही है? Can you hear me?
Yes, sir. I can hear.
Okay, good. Let me know when everything is set up and all ready. Can you see my slides?
Yes, sir.
Okay. Is it ready to go?
Yes, sir.
Okay. Okay. Thank you very much. First of all, I would like to thank Professor Yasir Saab, the Director UIIT, worthy Vice Chancellor of the Arid Agriculture University, Professor Kamar, and all I can see is few of my students over there. Thank you very much for providing me the opportunity to present the recent work we are doing here at ComSets in artificial intelligence for the healthcare. So you can see a lot of logos here on my front title screen. I'll explain this very briefly. The one you can see is NCAI. Now, NCAI is basically National Center for Artificial Intelligence. And under this center, there are 6 and 7 different labs. This is an HEC-funded project. And in Islamabad, we are also having one of the lab, which is called MID lab, Medical Imaging and Diagnostics. So the work we are doing here is basically under this lab. Before I start, this is a very brief and humble introduction of myself. My education is from Monash University and University of Wales in computer science in bachelor's degree from UK and master's from Australia. And then after serving a lot of different institutions, I'm currently in ComSets as working as a professor and dean, and also I'm the principal investigator of this lab. I had a chance to also look after the affairs of this institute, which actually you're sitting right now. So I was there for like 3 years. So anyway, so can you see my camera? Is it okay now?
Yes, sir.
Okay, fine. So my talk is basically today is in 2 dimensions. The first dimension, I'll give you a brief overview of what artificial intelligence is, and then relate it to the human intelligence and human brain. And then after that, I will switch to the work currently I'm doing in the field of healthcare with artificial intelligence. So you might have heard a lot about artificial intelligence, lot of gossips and talks going around these days about the artificial intelligence. I know of course it's a booming area. So if you look at artificial intelligence, then obviously you will see that it is if you decompose it, there are two words for artificial intelligence. One is artificial and the other is intelligence. Everybody knows that artificial is man-made. It doesn't exist, artificial. That's a literal definition of artificial. And the intelligence is basically the computation. Intelligence is a computation. And the computation that you do in order to achieve certain things, in order to achieve a goal. So what is AI then? AI basically is a discipline of making intelligent machines. We try to make machines intelligent and intelligent computer programs. So what we are trying to do is basically we're trying to understand the human intelligence, and then we expect from computers to do those tasks. So that's what basic AI is. So I see artificial intelligence in 4 different ways, okay? Now, the first way I look at artificial intelligence is the system that thinks like human. These are the systems. Then systems that think rationally. Rationally means logically. And the systems that act like a human, and the systems that act rationally. So if you take this square into 4 different boxes, let's look at these boxes. So we have one box for human. The other box is as rationally, that thinks rationally. Then we have some thoughts, and then obviously we have the behavior. So behavior is actually the acting the things. So artificial intelligence, human-like, first column of that square, or the first inner box of the square. Human-like means that how to simulate human intelligence and the human act or the behavior on the machine. So whatever we do, whatever we think, whatever the behavior we have, we want to translate it, map it to the machines. So you see that we are pretty much doing at the moment. You see a lot of the games, the puzzles, the mathematical problems, the common reasoning, the expert systems, the expert knowledge, the case-based reasoning systems, heuristic-based systems, agent-based system. These are all examples of the human life. Then there is another part, and that is rational life. Rational life means that we want to achieve the goals, and by setting certain parameters, by setting certain performance parameters, that if you achieve those parameters, then obviously you achieve the certain performance. Right. Then the thought processes. Now the thought process is that the new efforts to make computer think. So machine with minds, right? And in the full and literal sense, this idea started in 1985, but still we are working on it. That's the most exciting area where we want computers to think. At the moment, I will ask you what's happening at the moment. And then the behavior. Now we want the study of how the computers do things. At the moment, we as a human are doing it in a better way. So that's another behavior we are expecting from the computers and from the machine. So what is the vision of the AI? When we talk about AI, what we look at the AI? Okay, so if I ask you what you want from the AI, so obviously you want that if you go home, then your computer manage your emails. Your computer will interact or coordinate with your social activities. And you want your computer to plan your holidays. And you want your computer to look after your house when you are away or when you are on a vacation. So that's the vision of the AI. Now look at the latest technologies around you, the latest gadgets around you, the latest technologies around you, and map into the parameters. I just opened it up on the screen. I asked you, okay, tell me that is your current computer is managing your email, mapping or planning your vacations, coordinating with your social activities, watching your houses? No. If the things are happening like this around you, then you can say that that's where we are heading in the right direction, because that's what exactly the vision of AI is. Now, vision is separate. What is the goal of the AI? The goal is that we want to make computers more useful by letting them take over the dangerous or tedious tasks from the human. So that's very, very important, that whatever the tedious tasks humans are doing, we want the computers to do those. And that's basically human intelligence, because we are doing tedious tasks by using our human brain, by using our human intelligence, and we want computer to let it do it. So now this means that there is a relation between the brain and the computer, because when we are talking about human intelligence, then this means that we are talking about the brain and the computer. So AI is basically comparing the brain with the computer. So there are two things, as I mentioned. One is the goal and the other is the hope. At the moment, we are hoping, our vision is that brain is a form of a computer. That's our hope. And our goal is that we can create computer intelligent enough, whatever, through programming, through agents, whatever. So the people become intelligent, just as people become intelligent, so computer also becomes intelligent. But we see that computer at the moment is not acting like a brain. Brain is superior at the moment than the computers. So the computer performs tasks without understanding what it's doing. That's what computer is. It doesn't, I'm not saying, don't take me wrong here, but what I'm saying that computer is performing tasks just by himself or by itself. No, it's not like that. What I am exactly meaning here is that computers are performing tasks, but without understanding. They are programmed with ones and zeros. That's what they are performing at the moment. They're exactly following the instructions from you. Whatever you instruct the computer, computer does it for you. If you don't instruct the computer anything, computer doesn't do anything for you. So my question to the audience today is, and I want someone to answer this question after my initial discussion, that does the brain understand what it is doing when it solves problem? Does the brain understand what it's doing when it solves problem? Can anyone answer that? Anyone from the audience, can you answer? Does the brain understand what it's doing when it solves problem? It's very simple. Yes. Okay. Yes, it does. Our brain understands that. At the moment, the brain is superior. Okay. So I'm summarizing, right? What I'm summarizing at the moment is that AI tries to mimic human intelligence by learning. That's what AI is. Very, very simple. So a lot of human intelligence, and we're trying to computers to learn from the human intelligence. Okay, so foundation for the AI, computer science, mathematics, economics, cognitive, linguistics, biology, everything. Big questions. Yasser, can you ask someone to hold the mic for me? I want the answer one from the audience. Now, these are my questions to the audience. Can someone answer? Can machine think? Yes or no?
No, sir.
No, good. Okay, now you have to answer the next question as well. So if not, why not? Why not?
So because they don't have the capability of making a decision.
Yes, exactly. At the moment, they cannot think because we are not training them to think like this, like the human brain. Right? What does this say about human beings? Yes, human beings think. They always think. The human beings always think. So what does this say about the mind? Yes, the mind thinks, mind works. So what? Now answer me the last thing. And if we can make machines think, should we? That's a major question of this century. Are we trying, can we make machines think? Can we, should we, हैं कि नहीं कर सकते? क्या हम इस काबिल हैं कि हम machines को कहें कि वो think करें? Yes, but it's a very daunting task. It's a very difficult task. And that's what AI is doing at the moment. AI is now beyond the traditional way of mimicking the human intelligence. At the moment, we are trying to make machines think. And now how to start making the machine thinks, that's the process. That's what we are heading towards now. And this is a major task. So AI learns by using the large amount of data. So you can see here that the large volume of data, and then we learn from the data and we build the intelligent systems. That's a very typical three-tier architecture, you can say. So what are the components of AI? What are the components of AI? And first of all, AI has the agents, right? So the agent perceives from its environment, they learn from the environment. Then the other component is human sensors. Humans are sensors, our eyes, and then we have effectors, or we call them accutators. For example, the mouth, the hands, and then map it to the robot. The sensors are the camera, the laser radars, and accutators, the effectors, the grippers, the manuators. So that's a typical components of the AI. So the robotics is you see here, they are the mechanical parts, and then the AI parts, and then we have technologies where we are using this in the vehicles, in the soccer, in the rescues, and a lot of different applications. You have seen already games, a lot of classical games. A very famous game was the Blue Chip versus Kasparov. That's also being on the AI. And then that was the first time that the machine, they beat the Blue Chip, beat the humans. Then it involves in the decision making, scheduling, routing, fraud detection, and whatever you name it, these are the applications. So artificial intelligence can be applied in a lot of different domains: education, health, smart cities, accounting, environment, finance, business. But what I'm focusing today is on the healthcare here. So successful applications of the AI, you can see IBM Watson, right? You can see Tesla driverless cars, and then you can see 3D modeling, Blue Chip, I just mentioned, Shenzhen, sound recognition, Google Translator, and then the Google and the face image recognition, and Shazam, that's a song recognition. And then obviously you don't forget about the Siri and Alexa. They are also the applications of the AI. So other application areas, a lot of text classification, bioinformatics, videos, images, classifications, composition, NLP, whatever. But at the moment, healthcare is a major player for AI. A lot of applications in healthcare. So AI is bringing a paradigm shift to the healthcare, powered by increasing the availability of the healthcare data with the rapid techniques. So AI can be applied with both on the unstructured and structured data. Popular AI techniques that are being applied in healthcare domain is basically a machine learning, then your deep neural networks, and then your support vector machines and all the other stuff in all the areas, include starting from cancer, neurology, cardiology, everything is being applied in this area. So now a brief kind of work that we are doing here at ComSets in my lab for medical imaging and diagnostic lab. So what we are doing here is very, very simple. By using the AI and deep learning modules in medical imaging, physicians, they identify the conditions for early promoting and detecting. So we envisage that AI can detect and diagnose cancer by analyzing the scan as well as it can assist the pathologists. So we have basically developed 3 AI-based products for brain tumor detection, breast cancer detection, and diagnostic system for the lungs. So that's the one of the major aim for developing these products. This is a HEC funded project for more than 100 million. And we are in the final stages of these products, and they have almost developed the products, and they are about to market. In fact, we have placed and launched it to a couple of places around us. And then the second thing was the capacity building. And the third was building the relationship with healthcare industry and the academia, that we have successfully did that. So 3 diagnostic tools we developed at MID lab. As I just mentioned, one is called Tashkhis, the other is TDS, and the third is BrainWiz. Tashkhis is the breast cancer detection, TDS is tuberculosis detection, and Brain is a brain tumor detection. So these are the three products. So we extracted the features by using different algorithms. So these are the list of algorithms we used for, first of all, the feature extraction from the data set. Initially, we got the data set from the benchmark data sets, but later on, now we have the data sets from the local labs, such as from PIMS, Aga Khan University, and then diagnostic centers, and then a lot of cancer hospitals like Noori and Shaukat Khanum, and also the Indus. So these are the places where we got the local data sets, and we train our models on the local data sets. So Tashkhis is the breast cancer system we have developed using the AI techniques. So most of you who are familiar with the machine learning, they can understand what I'm talking about. So because breast cancer is a very, very prevalent cancer worldwide, and you can see, according to the WHO, 2.3 million new cases in 2020, and there are more than 685,000 deaths globally. So what we did, we started with gathering the data from the public domain and from the local domain. As I said, DDSM, MIAS, and the local PIMS. We got the data set. We hired the technologists, because the problem here we faced is basically the labeling of the data. You understand, those who have knowledge of the machine learning, they will probably understand what I'm saying, that the labeling of the data was a very, very difficult process for us. And we are not the the medical specialists. We means myself and my lab. So we have to hire a technologist who can label the data for us. So we labeled the data. We did all the pre-processing here. We did the data annotation. We sometimes do the data fusion and the augmentation here. So these are the steps we did. And then we train our deep learning models. So the models we trained here from the data set, and then we deployed those models to do some classification from normal, malignant, and non-malignant, and abnormal behavior. So that was the high-level kind of task. I'm not going into too much details, but that's the high-level task we did for our breast cancer. And then we detected, this is the image you can see, and then we detected the suspicious regions, malignant, benign, and normal. And we also did an extra feature here. We localized the suspicious region in the full mammogram. And we did some localization. That was a very difficult task, which we did. So we also identified that which dense tissue of the breast hide cancers in the mammogram, because that was a challenge faced by the radiologists. And it is hard to tell the difference between a tumor and the breast tissue, because I just said that dense tissues of the breast hide the cancer. So it's very difficult to differentiate. So we not only did some classification, it's not just we took the data, applied deep learning models and do the classification. It's not like that, all right? It's not that simple. It looks like, and the way I'm presenting it looks simple, but actually it was very difficult to differentiate between the tumor and the dense breast tissues. This is basically the DICOM viewer we developed. And this DICOM viewer, you see, this is the image. And this is the tool we developed. It has all the features, and currently in our country, all the radiologists, they don't have this kind of tool with all the integrated facilities. And you can see, you can zoom, you can magnify, you can contrast, you can rotate, a lot of work you can do. And this here is that's the part where you can see that the abnormality. Okay, so if you look at this, the abnormality score is 91%. And then the density, which I was just mentioning, it's scattered to fibroglandular density. And then we have suggested the densities as well. So once you do the submit, it generates the report for you as well. So that's how our DICOM viewer works. These were the challenges. Availability of the local data, mammogram resolutions varies from local and the public data. So alhamdulillah, we overcome that. Then the second product we developed was a tuberculosis diagnostic system. Again, the common disease, it's very common, TB, it infiltrates or consolidate, and the cavity often seen in the upper lungs. And then in Pakistan, we are currently, unfortunately, we cannot eradicate it, and it's ranked in the 5th among the countries. And this disease is basically still a very dangerous disease. So we took that and we got the data set for it. Our objective was, again, to develop an AI-based CAD model so we can automate the identification of the tuberculosis and for the common lung diseases. So this is, again, what we did is we took the input, that's our system, and we produced the output. You can see on the output, it's the area where it is highlighting. So let's look at the pipeline. That's the pipeline. We again took the local data sets for the tuberculosis. We again have the medical technologists for labeling the data. We did some annotation here, did some pre-processing, removing the noise in the text, applied transformers, deep learning models, SWIN transformer we applied here. And then we did some model verification and then deployed the model. So that's a typical top-level pipeline for our diagnostic system of tuberculosis. And that's again a top-level model who people who are machine learning specialists sitting in the audience can easily see what we were doing, very top-level feature extraction, selection, and then the prediction. That's the DICOM viewer of our product. Again, you can see this is the image of a patient carrying the TB, and we diagnosed that is tuberculosis is 91% with right and lung polyphora. We are mentioning that polyphora. And then after that, the same tool I showed you for our Tashkhis product, that's a DICOM viewer. And you see here, can you see this is the red area here? That's basically where the tuberculosis is. That's what our diagnosis, when we put the image or loaded the image of the patient having the X-ray of a patient having a tuberculosis, then our system diagnoses it with the red area. So that basically that our tools are helping the radiologists by using the AI techniques to identify these things. These were the challenges. Yes, obviously we failed because deep learning models are data hungry models, you all know. So we faced a lot of difficulties in getting the data. In Pakistan, the problem is that, again, people are very reluctant to share the data. But again, we were fortunate enough, after a lot of struggle, we gathered some local data sets. Last product, BrainWiz. BrainWiz is basically skull stripping. So it's a tumor segmentation. We did an overall prediction. So BrainWiz, again, a very simple model. We took the MRIs now instead of mammograms. We took the MRIs, passed it to our product, and then we predicted the survival prediction of the patient, right? And again, the accuracy was very, very fantastic actually for for the brain tumor. We wasn't expecting that much of accuracy. This is a very top level model pipeline for the brain. Again, we gathered the local data set. Most of the data set we got from Aga Khan University, Karachi. They are doing a lot of work on the brain tumor. So credit goes to Professor Dr. Atarinam, who helped me to get these data sets from Aga Khan University. We are very thankful to them. And then the data annotation and the medical technologists, they are working here, labeling the data, did some pre-processing. Here we used UNet model of the deep learning. And then again, after validating the model, we deployed this model. So this is a brain with, again, scanned MRIs, survival prediction. We did some segmentation. Okay. Now, important thing is, you know, the BRATS. The BRATS has a leaderboard segmentation score. So MID Lab is being the first. Our product is basically second for the last 1 year on the leaderboard of the BRATS data set, on the BRATS competition. Our accuracy is 0.75, which is 75%. And it's of our 3D model, and 2D model is 70%. So we are unbeaten for the last 1 year. And we are still on the second position for the last 1 year. So that's a big achievement of our product. Then that's the CAD system, the whole system for the brain tumor, the DICOM viewer. You see the DICOM viewer here. It's a 3D modeling now. So you see here the brain, and that's the part where its severity level is 85%, and the survival rate. Allah better jantal, but the machine predicted it that the patient has unfortunately 110 days to survive. So that's the manual versus AI diagnosis. It's more accurate. In the manual, there are chances of high errors, and it's more time consuming. So what we have done by making these products, we achieve a high accuracy. It's faster. It reduces the time. We can work on multiple modalities. It is less costly. And once it's trained, it can handle multiple cases. So that's our success. Then these are the benefits we got out of these tools. Obviously, we face certain challenges, some ethical issues, large amount of data. Data tagging was one of the issues. It's very hard to get involved, the technologists, and they were labeling the data for us. So finally, I leave it to the audience. Now you think about it. Can we make something that is intelligent as human? Can we make something that is as intelligent as a bee? Can we make something that is evolutionary? Can we save the plant 20 millions by pattern recognition? Can we save the bank 50 millions by automatic fraud detection? Can we start a new industry of handwritten recognition agents? So these are all the tasks which we can expect from AI to answer. So these are the AI questions. So that was pretty much from me. I have taken half of an hour, which was allocated to me. Thank you very much. Any questions from the audience or anyone who wants to comment? You're most welcome.
Have you any questions, please?
Sir, thank you very much for the talk. And my name is Dr. Rehan. I'm assistant professor at UIIT. So the first question, because you have so much of experience, and I've got an opportunity to interact with you through this workshop. So I just wanted to
I cannot hear you.
that we can reach the point of intelligence which our brain has, because the ultimate goal is that.
Dr. Saab, sorry to interrupt you. Can you repeat your question again, please, very precisely? Because I missed the first half of your probably the question. Yeah.
Right, sir. Okay, sir. So, sir, my question is very generic, but at the same time, it's important for us also. As a researcher, I sometimes think that is it possible for us, by us or by we, I mean that all the researchers who are working in this field, that can we reach the capability of a human brain as the ultimate goal is that we want a machine to be similarly intelligent as a brain is. So can we achieve that point? Although we have some limitations and the algorithms are not that intelligent, but is it possible a time comes that when we say that a machine is equally intelligent as a human brain?
Thank you, Dr. Saab. It's obviously it's the same question I asked from the audience, and that question has bounced me as well. But I'm ready and happy to answer that question. Dr. Saab, the brain is kind of has an immense kind of knowledge and the power, I would say, computational power, the brain, right? And machines at the moment they don't have. That's what we are expecting from the AI, so they can perform and they can do the acts, and their behavior should be like the human brain and the human intelligence. That's what the aim of the AI, to inculcate the human intelligence into the machines, right? So human intelligence cannot measure at the moment. It's huge. It's tremendous. It varies from human to human, right? So you can't say that at the moment we are transferring exactly all the human intelligence to machines. So one question answered at the moment. At the moment, no, it's not. Now, the second half of your question is that do we expect? That's what we are striving for at the moment. That's what we are struggling for at the moment. We want to make the machines intelligent, more intelligent, or equally intelligent as compared to the human intelligence or the human brain works. So I would say that we are moving in that direction. The success is yet to achieve, right? But you look at the Tesla cars, right? The autonomous vehicles, right? So they are like a human brain sitting on the wheel. What it does, using all the intelligence in case of a catastrophe, in case of an accident. So we are trying to transfer that ability and the thinking to the cars, to the Tesla cars, right? To the autonomous vehicles. So I'm not in a position to tell you the exact percentage, but I can tell you one thing. Yes, we are heading towards it. And that's the real AI. That's the real AI. This is not the AI exactly. Well, I mean, the product which I explained to you, obviously it's an AI, but it's not up to that level. But I can give you another example. The robots they're trying to experiment that robots will do the surgery in coming years. So what a surgeon does, lot of intelligence at the runtime. So we are trying to inculcate in the robots. So definitely that is coming, but I cannot guarantee you how much and when. Thank you. I hope I answer your question.
Thank you very much, sir, for valuable and informative talk on artificial intelligence and its relation with human brain, along with in healthcare. To acknowledge our respected keynote speaker, I request Director UIIT, Professor Dr. Yasir Hafiz, please come over here and present the shield and certificate to Professor Dr. Suhail Askar. On behalf of Professor Dr. Suhail Askar, I would like to call Mr. Pras Bibi to receive the shield and certificate.
So thank you very much.
To acknowledge respected speaker, Dr. Muhammad Shuja Islam, I request Director UIIT Professor Dr. Yasir Hafiz to present the shield and certificate. On behalf of Dr. Muhammad Shuja Islam, I would like Ms. Pushpa to receive the shield and certificate.
Can I leave, Yasir?
Thank you very much, sir.
Thank you.
Thank you very much, sir. Now I would like to introduce the next keynote speaker, Professor Dr. Ataul Aziz Ikram. Dr. Ikram is currently working as professor at FAST National University of Computer and Emerging Sciences, Islamabad, Pakistan. He has supervised numerous PhD students in the area of bioinformatics and mobile network networks. He has completed HEC National Research Program for universities and RPU funded projects in the area of cloud computing, and more recently, Technology Transfer Fund for development of Indoor circuit and collaboration of local fan industry. I would like to invite Professor Dr. Ataul Aziz Ikram to present on IoT, the big picture.
Can you guys hear me? Yes.
Yes.
So, title of my talk is Internet of Things, Big Picture. When I was requested to present on Internet of Things, I was wondering what could be of value to researchers that is not traditional knowledge that you gain from reading papers, but a more comprehensive sort of a discussion on what is Internet of Things doing these days and what can we expect to see in the coming future. Can you hear me at the back? Show of hands. Raise your hand, please, if you can hear me. Okay, so the talk is going to be starting from the global challenges that we face, and then what the current technology of Internet of Things is today. How can we use technology to leverage the challenges of today? Then we'll see some real world implementations of Internet of Things in different parts of the world. We will see some statistics and see how much business potential Internet of Things has. What are the global players this year, 2022? What is the landscape of startups that you have? What kind of startups are there? What are they doing in 2022 this year? And see what can we expect Internet of Things to connect to in different domains in the community. Okay, so I hope you have heard about the Sustainable Development Goals. Yes or no? Yes. So the concept was to build a global partnership for sustainable development to improve human lives across the globe and protect the environment. So the SDGs for Sustainable Development Goals were adopted at the United Nations Summit in September 2015. And I'm sure you have seen this picture. These are the 17 Sustainable Development Goals. We have no poverty, zero hunger. This is what we're striving for: good health, quality education, gender equality, clean water and sanitation,
affordable and clean energy, decent work and economic growth, industry innovation and infrastructure, reduced inequalities, sustainability, responsible consumption and production, climate action, life below water, life on land, peace, justice, and partnerships. And they are, you've heard about the fifth generation that is coming up, IoT, you have heard, genomics, AI is very popular, very famous keyword, AI in pretty much everything these days. 3D printing, digital extended reality, which includes augmented reality and cloud and edge computing, blockchain, quantum computing, nanotechnology, and big data. So,
Mike. और वहां पे नहीं हो रहा ना कर क्या कर रहा है काम करेगा दरकार
so we need more battery power, more efficient battery.
चला देते हैं ये नहीं चलता उधर से निकालो चौधरी का
Okay, so I'm back. Let's continue. So, what is IoT? Different companies have their definitions of Internet of Things. I'm going with Oracle's definition, and your definition goes: Internet of Things describes a network of physical objects that are things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. Basically, you have things that process information, that have sensors to gather this information, and then you have a network at the backside where you can transmit the data and more costly. So this is a a graph of the projection of devices that will be connected to the Internet of Things. You can see it's about 29.4 billion devices by the year 2030. It's a huge number. What are the application areas of Internet of Things? We have smart spaces, which means homes, buildings, and cities. Then we have self-driving cars. We have smart retail, wearables, industrial IoT, smart supply chains, and logistics, transportation and traffic management, water and waste management. And then we have the applications of Internet of Things in the health sector, agriculture, education, and environment. So these 8 or 9 SDGs can be actually modified or enhanced with the use of Internet of Things. And this is a table showing which areas of Internet of Things or which solutions leveraging the sustainable development. So for biohunger, you have precision agriculture or smart agriculture. For good health, we have smart healthcare solutions. For quality education, we have smart education. Clean water, we have smart water solutions. And by smart, I mean we have sensors, and then we have some intelligence that does some analytics, and you can modify the process of, so for example, you can do some cleaning or etc. Affordable and clean energy, so have smart energy solutions. So basically, energy management is one important goal. Then you have industry innovation, so you have industry 4.0, you have heard of it, and sustainable production. You have sustainable cities, so you have quality of life and cities. For climate action, you have smart environment. You monitor the air pollution, you monitor the air quality, and then you do some remedial actions for that. Then you have peace justice, then you can have some apps for smart governance, etc. So this is a table. I'm not sure if you can see font size is pretty small, but essentially all of the areas that I've mentioned in the SDGs that can use IoT, they're pretty much all covered in a number of solutions that have been deployed in multiple cities in the world. So we have already real world cases, where, for example, in Barcelona, we have smart government. Similarly, in Amsterdam, also, the concept of e-government has been implemented by web-based applications. Similarly, smart living and infrastructure in Los Angeles, Dubai, they have smart buildings, they have smart homes, they have smart. So these real world cases are already being implemented in multiple cities around the world. So again, smart industry in Sweden, cybersecurity has been deployed, industry 4.0 application, smart energy, we have energy management that have already been deployed in multiple cities again. And so this is sort of a summary of what is already being done around. Now let's see a few statistics that of business values that are there, so you can have a sort of a motivation for why IoT needs to be or has been. So 64 billion IoT devices by 2025 is the expectation. 4 billion to 10 or 11 billion by 2025. Similarly, automation will reach 150 approximately billion in revenue by 2027. Again, compared to the GDP of Pakistan, similarly, wearable device market itself is $1.1 billion. Internet of medical things, $158 billion. So you see, if the skilled people of Pakistan can sort of take part in the development and design or research and development, you can contribute to the economy. Pakistan around. So again, IoT security market is $6 expected by 2028, etc. Let's look at the big players as expected. You see IBM, Intel, Microsoft, Google, also Cisco, AT&T, and Amazon Web Services. Dell, etc. These are the big players. And there are some companies that you may be familiar with if you're doing some prototype development and you need some board. The single board computers, we have Raspberry Pi, which is very popular. We have the Fusion board, we have Technical Cell, we have NVIDIA Jetson. Basically, what you have sensors and then data acquisition module and then data processing module and the communication module all on this board. And this board serves as an IoT device for development of prototype. Rapid prototyping is really one step, and for the startups, it's really useful. You have an idea, you develop the idea over a board, show it to somebody and see if you're interested in taking it forward, investing in it, or collaborating with or sell your idea. So some IoT companies again, Anderson, Sciencesoft, these are big companies that are doing some IoT development, the software development for the IoT or IoT networking, etc. And they are they have good revenue streams, like $20 for Anderson, $20 million for Sciencesoft, and these are very old companies, like they're like 10 to 15 years old. And then we have startups, and also there are a lot of startups doing work in Pakistan. I have just I'm just mentioning the 2022 profile of the US. This is just just to give you some idea, but you can see typically analytics, cloud platform, or management system, cybersecurity companies, they're all domains of the IoT that these startups are working in. This agriculture IoT startup by the name of XFarm. Then you have business insights called Seek. Then there's Samsara that connects for connected operating systems. So basically, have you heard the term digital transformation? What is digital transformation? I just asked this question to make sure that I'm getting it away. You're laughing if you're awake, but are you focused? So what is digital transformation? You can't see it coming. ठीक है, आसान लफ्जों में आप आईटी को इस्तेमाल करके अपनी कंपनी की परफॉर्मेंस को बेहतर करें. So you put your business processes, overall जो जहाँ आप आईटी इस्तेमाल करके चीजों को बेहतर कर सकते हैं, आप वो करते हैं उसको. So IoT is the key driver for digital transformation. It is going to create new business opportunities because आपकी efficiency अगर अच्छी हो जाएगी, आप प्रोडक्ट अच्छी करेंगे, आप के पैसे बचेंगे, तो आप बिजनेस सेट आपकी कंपनी बनाने सकते हैं. You will have new revenue streams. कहाँ से पैसे बचेंगे, क्या नई प्रोडक्ट है, IoT किस डोमेन में अप्लाई हो रही है, वो इतने रेवेन्यू स्ट्रीम है. तो ये क्या अपनी देश पे काम करें, आप IoT को इस्तेमाल करके या IT को इस्तेमाल करके और कुछ भी कर सकते हैं अपनी कंपनी के अंदर ज्यादा डेवलपमेंट के लिए. So improved reliability, customer satisfaction. Depends on yes, you want your customer to be satisfied by performance. How will IoT leveraging the environment? Have a lot of sensors that are deployed, and then you gather a lot of data, and this data can be improve the environment model, statistical model, and that can help you predict more accurately how the environment is behaving. So IoT is going to help you in this way as well. Then you have the green economy. You are saving energy. You are improving the efficiency of your operations generally. So if it's a small industry, it's a small company, it's building, you are less resources. So less carbon emissions, which means a better green economy. And then you can, of course, using this model, improve more and more people are now more aware, they are more concerned about it. So when you say you say that your footprint is carbon footprint is small, people will be more interested in investing in your buying your car. Then there is the concept of circular economy. So the linear model is when resources, goods, and these goods go to waste. You get some resources and then you have some waste at the end. So this is the linear model. The circular model is when you try to reuse, remanufacture, and recycle materials. It's like a loop, like a circle. And so you will be wasting less. So IoT enables creation and processing of the data and information required for circular business model. So now you are going into circular business model compared to linear. IoT along the way is going to help you and make this more efficient as well. Then you have quantum computing. Quantum computing divided now. How is quantum computing different from traditional? Okay, so I'm going to go forward because so quantum computing is based on the concept of quantum mechanics, and so the idea is superposition, entanglement, and interference. What are these? In a traditional computer, which is based on binary computation, you have two states. You have a 0 and a 1. In quantum computing, you have simultaneously multiple states. There is a possibility of the 0 and the possibility. So it's not that you have a 0 or a 1 happening. You have this cloud of probability, and you use this to make more complicated computers compared to the traditional binary computer. The data is held in qubits. And qubits can be entangled. Entanglement means that one state of the system affects another state. So, and these days you might have read that they are trying to entangle multiple entities over longer and longer. And so that means, for example, that if you have data here and you do some operations here, and you have data millions of miles away, you don't need to transmit the data. You just do some process here, and because of entanglement, that just gets shifted to the other part to the same data, which is millions of miles away. So instead of transmitting, you're just entangling, and you think you're duplicating the data over long time. So most complex problems can be solved much faster using quantum computing because we have more number of states and we have much bigger circuits confined to smaller sizes. So IoT is built on sensors and devices, and you can use the power of quantum computing to make better IoT. Then you have nanotechnology. You will be able to use nanotechnology again to improve the performance of fighting. For example, make nanoscale-based antennas for IoT boards. They can be scaled down to size, and more powerful processors can be made again based on nanomaterials, nano devices. How about blockchain? So what is blockchain? Blockchain is basically a shared ledger that facilitates the process of recording transactions and tracking assets in the business. What are assets? Assets can be tangible or untangible. A tangible asset is the house, for example, car, cat, and intangible is intellectual property, patent, copyright, and so on. And you might have heard about NFTs these days. Money using NFTs. These are basically intangible assets, but they have intellectual value. So you can do artwork and you can sell it. So blockchain essentially does not need centralized system, and you can use IoT. You can use blockchain to secure, you can make it a distributed secure layer on top of the IoT that's already. So blockchain can help IoT. This is something that I'm sure we have studied or examined. What are the research areas that are hot in IoT? We have technology stacks in the middle where, again, agriculture, industry, and environment, these are the areas where IoT research is done. Standardization is very important because you have a lot of layers coming in, so you need to have certain courses, certain interfaces that need standardization. So you have interoperability of different type of devices. Different companies are making different devices. Different company devices will be able to communicate. So again, and security is an important aspect. IoT research area because we have a lot of devices. You have a lot of exposure to the market. So maybe taking a lot of nodes security is much more challenging than taking some nodes. Similarly, data processing environments or analytics are research areas in IoT. Smart city I have mentioned, more and more research is being done, and also because we're expecting with the size of the devices to get much smaller, we see a larger number of devices. Okay? And so scalability is the interesting. So IoT is one of the biggest drivers of transformative technologies. A lot of transformation is going to be expected because of IoT. Critical challenges exist for adoption of IoT, standardization and scalability as mentioned. IoT begins such as quantum computing, blockchain, nanotechnology, and these nano-based materials will enhance the capabilities of the Internet of Things and also help make IoT. Any questions? Pardon?
PG.
Very good. Problem is, you can make sensors based on material. So the first thing would be you need some sort of a plan. That may be done. You can make and people are doing that. Start having very high and maybe a computer.
सवाल करे तो मिट्टी बात नहीं आएगी वहां से बोलेगा तो यहाँ आएगी बाहर से
Investment is going to be much larger if we have fewer technologies for sensors. If somebody is able to invest, yes. At one stage in the research that we were doing, I asked my students to come up with a design of a board similar to a Raspberry Pi. But again, the problem is that we need to get it manufactured. If we have the capability developed in Pakistan, yes, we can. Because when we talk about IoT, we say there are billions of devices. Who is going to manufacture it? Not one company. So there will be a lot of companies. So we can have a Pakistani company doing that work. It is specialized. Maybe we have to if somebody can invest, it has. Any other questions?
Thank you very much, sir, for an informative talk on the big picture of IoT. To acknowledge our respected keynote speaker, I request Director UIIT, Professor Dr. Yasir, to please come over and present the sheet and certificate to Professor Dr. Ataul Aziz Ikram. Thank you very much, sir. Our next speaker is Dr. Akash Ahmed, who has joined us from Germany. Dr. Akash is currently working as an assistant professor at the School of Computing and Communications, Lancaster University, Leipzig, Germany. Dr. Akash's research and development expertise are in the area of software engineering, with its applications to mobile and Internet of Things for smart systems and infrastructure. Now I would request Dr. Akash to please start the online session on engineering software intensive systems for the Internet of Things.
So much. I hope you can hear me now. Yes, can you hear me? Can you hear me?
Welcome, Dr. Akash. We can see your screen.
Yes, thank you so much. But can you hear me as well?
You may start your presentation.
Yes, but can you hear me?
Dr. Akash, can you hear me?
Yes, I can hear you, but my question is that can you hear me as well?
Yes, we can hear you, but your voice is quite low.
Okay, is it any better now?
A little better.
Okay, just let me speak for maybe 10 or 20 seconds, and if there is an improvement, let me know. Otherwise, I'll just try to switch my mic. So can you hear me clearly, properly? Just 1 second. Okay, is it any better now? Can you hear me? Okay, is my voice clear now?
So your voice is not clear.
Okay, now?
Yes, now we can hear you.
Okay.
Yes, you may
Okay,
start
so
now.
okay, I'm gonna start. I'll just try to stick to the time limit, but in between, if there is any problem in the audio or video, just let me know. So yes, moving forward, my topic is engineering software intensive systems for the Internet of Things. In simple words, this is SE, software engineering for the Internet of Things. I am Akash Ahmed, working as an assistant professor at the School of Computing and Communications at Lancaster University, Leipzig in Germany. And it's my pleasure to be a presenter at this first international workshop on AI and IoTs. All credit to the worthy Vice Chancellor as well as Professor Yasser for organizing this initiative. Just a bit of academic background. I have my bachelor's in software engineering from International Islamic University. Then I was a software engineer at Elixir Technologies. So this very institute, the University Institute of IT, this is where I started my academic career. So in Professor Yasser, I not only see an academic, but my mentor as well, like a brother. So it's always a privilege whenever he calls upon
Excuse
me
me,
to.
sir, the screen is not updating. Please share your screen.
The screen is shared. Let me.
Yes, now we can see the updated screen.
Okay. Yeah, please let me know if whenever there is an issue, just let me know and I'll try to fix if there is an issue with the audio or video. So after my stay at the UIT, I moved to Dublin City University where I had my PhD in software engineering, my postdoctorate from the IT University of Copenhagen. In between, I had a short stay at the University of Adelaide as well. And this is where my career actually starts as an assistant professor working at NUST, University of Hail in Saudi Arabia. And then I joined Lancaster University, Germany, which is a pretty much global university. It has a campus in the UK, Germany, Malaysia, China. It's growing. Moving across the globe. Here is the scan me tag, which you can scan to check more about my research. But the agenda for today's presentation is software engineering for the Internet of Things, software engineering for steric computing. What do we mean by steric computing paradigms? I'll talk about it briefly. Some of the recent projects that I am involved with, and then some dimensions of future work and recap. So just going with the background of.
Sir, we cannot see your updated screen.
Okay, let
Sir,
me
can you
try.
please slideshow the PowerPoint slides?
I'm slide showing them. Just give me just 1 second. It's just a bit of inconvenient. I think, I don't know, there is some issue with the Zoom client. This is why I always prefer the Microsoft Teams. Anyways, can you see now the background?
Yes, we can see.
Okay, please
But
think.
we're still not able to see the slideshow.
Okay.
Slide mode.
I am in the slide mode. Just 1 second. Let me go again. Share. Hopefully it should fix the problem. So can you see now?
Slideshow.
We cannot still see the slideshow.
Okay, 1 second. But can you see the screen?
Yes, we can see the screen.
Yeah, that's okay. I mean, there are not too many slides. If there is a problem, I'll just try to switch on. I don't know why it's acting up, but let's keep moving. So you can see the screen, all good, right?
Okay. Yeah.
Okay, so I hope you, whenever the screen disappears, just let me know. Sorry about that. But anyway, software engineering, as we know from our bachelor's degree and the introduction to software engineering and all that, it's an engineering discipline that helps us to design, implement, test, deploy software systems effectively and efficiently. We have the software development life cycle, where we have the ideas, requirement, design, development, testing, and all that going on. So this is like the software engineering that every undergrad, postgrad student knows. Then we talk about the Internet of Things, which is quite the buzzword nowadays. Everyone talks about Internet of Things. Very few know what exactly is Internet of Things. because there is no universal definition, there is no universal conception. There would be definitions from Microsoft or Google and all these big tech companies, but they are the definition that suits their businesses. My perception or interpretation of Internet of Things is devices, sensors, humans, softwares that are interconnected to perform some computational tasks. This is how a typical IoT ecosystem would look like, where you have different devices, your vehicle, your house, they are actually connected to do something common. Smart home, smart technology, smart transportation are typical example of the IoTs. Okay, simple enough. SE, IoT makes sense. Now it's more interesting when we combine SE plus IoT, where we
So
try to
your slides
apply.
are stuck again. Yes, now it's updated.
Okay, is it moving now?
No.
Okay, let me try to find a bit more sustainable solution to this,
Now it's
because
moving. Now
okay,
we
let
can
me
see the
keep it.
background fine.
Okay, because I just ended this slideshow, so that's why maybe you are able to see. But anyways, let me keep it like out of the slideshow mode. If it gets stuck, just let me know. Do not hesitate. I'll just try to fix the problem. This is my main the most important thing. Can you see now? Moving, new slide.
No, sir.
Okay, can you see now?
Still no.
Still no, I don't know what is
SE
it.
for IoT. We are seeing the slide SE for IoTs.
Yeah, this is the SE for IoT, but I mean, do you see this kind of a block diagram? Because on my screen, it regularly updates, and I don't know what can be the problem, but it's actually slide
Why
number
don't you
6
move to
somewhere.
the next slide so we can fix the problem now instead of interrupting again.
Yeah, can you
Yeah,
see
now
it
we
now?
can
I
see the
mean,
moving slide.
okay. So
Now we
anyway,
can see the moving slide.
I'll just try to keep it out of the presentation mode. Hopefully it will be more smoother. Anyways, so here is one of the model taken from one of our paper. It was actually three-dimensional thing in a way, not three aspects, I should say. The view for the Internet of Things that is on the left here that you see here. Then there is a software engineering view where you have to analyze, design, deploy, test, maintain, and do all these things. And then there was a data analytics view. So I would just keep the data analytics part out of this and focus on the Internet of Things and software engineering, because this is mostly the agenda of the talk, how we can apply the software engineering principle and practices to develop Internet of Things. Because when someone talks about IoTs or the Internet of Things, the by default human understanding is that it would be some sensors or some devices that actually helps to automate something. That is fair enough, valid enough. But there is a bit of unsung hero, which means something which is a very vital part of the IoTs, but it remain largely non-discussed. That is the software. And to develop software, we need to do software engineering. So that is the whole idea. You apply software engineering to the Internet of Things. Moving forward, I hope this slide has transitioned. So now you should be able to see software engineering for steric computing. This is not a standard term, steric computing, but steric means almost anything. Because nowadays, when you start to learn about cloud computing, you see blockchain, you see IoT or whatever. So every 6 months, there is something new coming out, because these technological companies, they mean business and they just need to keep inventing something new. So we had cloud computing and we needed software to ensure that we have resource elasticity, we have the paper usability, we have the multi-tenancy. Cloud computing example is very similar. Let's say in our daily life, we have two options. If we want to travel, we want to keep a car. And if we keep a car, we need to have the fuel prices, we need to do the maintenance, we need to learn the driving. The other option is to buy or hire a cab or get maybe Uber or Careem. where you will be paying as much as you utilize. So same is with the cloud computing. You don't need to have computing infrastructure to maintain, to buy. You just need to utilize the computing infrastructure and you pay as you go. So this is one of the classical example from real life to cloud computing. So cloud computing helps you to utilize computing infrastructure, the pay as you go, like Dropbox and all that. Although we use mostly the free versions, but if you are a corporate, you need the paid version of the Dropbox where you don't need to install hardware devices or hard drives. You just utilize and you just pay according to the space, according to the storage space that you acquire. Then we have the blockchains, which are at the very underlying level, the linked lists in the data structure terms. But blockchain as a philosophy, as a concept, as a technology actually is much broader than that. It helps you to have distributed ledgers and all that. And then we move towards something which is the Internet of Things, where we have the portability, we have the context sensitivity, we have enhanced connectivity, which mean these IoT devices, they help you with more mobility. They help you context sensitivity, which helps you to sense the context that you are in. It might be listening to your voice. It might be knowing your location. This is called context sensitivity. So mobile devices and IoTs, their biggest, I should say, strategic advantage is based on the fact they are portable and they can sense your context, where exactly you are, what you might be doing. And based on that, they actually adjust the computing or computation capabilities. But the problem is resource poverty and energy limitations, that the power and computation resources on these sensors or devices would be very low. One typical example of an IoT device could be your mobile phone or smartwatch. It's very mobile, very context sensitive, but the processor is limited and the battery is limited, which actually creates some engineering problems and challenges. Underneath that, you can see the IoT or Arduino, which are the frameworks to develop IoTs. This is something more interest to the developers who like to see the practical side of the IoTs. So this is the steric computing, I could say. One of our worthy speaker was just mentioning about the quantum computing. I am working on software engineering for quantum computing as well, but hopefully that's a topic for some other talk. But the thing is that this stack of computing technologies keep growing on from time to time. Now we are focusing on the IoTs, so I'll just stick to the IoT. So projects on SE for IoT could be of two types. One could be more foundational research, where you try to establish the processes, patterns, models, frameworks for the Internet of Things. Other could be more applied research, where you try to develop the smart systems. I'm just going to switch for 1 minute. Hope you can see this screen here. Can you see it now? Is it stuck or can you see now?
Yes, we can see.
Okay, that's good, because what I wanted to see, sometime in our undergrad, some teacher introduction to software engineering teaches us the pattern and we say, what the hell is he or she is talking about? It doesn't make sense. We are here to learn coding. But at this stage, then you start to learn or realize the importance of patterns, and layered pattern could be one of the prime example. It helps you to create layering in the system, where we have a sensor layer, that is the hardware devices or whatever control in between, and then we have the software layer. So this is where the software engineering comes into play to design or develop the IoT system. I'll try to share a practical example with you as well, where we applied the layered pattern and it helped us to create a software architecture, software model implementation for the Internet of Things. Okay, so moving on to a bit more interesting things that we did here. We are working on Internet of Underwater Things, where we would like to study what happens under the ocean or in the water, because we would be interested to measure certain parameters, the acidity of the water, sunlight, temperature, the Arctic life, or the, how should I say, the life under the sea. And on the top, we can see domain view. Domain view is always the view of the real world. So if you are going to solve a problem for some management information system, accountancy, HR, the HR department, the financial accounts will always be the domain view. So here the domain view is like the seawater, where we have some deployed sensor, we have the sea life, we have some pollution or whatever under the sea, and we have some deployed sensors. And under that is the architectural view, which actually help us to model the domain view, the real life world, to the software world or the software side of the thing. So one lesson to take away, especially if you are a master student or undergrad student, always be creative, try to analyze, visualize what's happening in that real domain model and how we can connect that to a software world. Mapping is all that matters if you want to be an exceptional software engineer, software developer, or software researcher. So basically, domain view is the real life view, and architecture view. Architecture is one of the integral part of software engineering. It helps us to map that real world problem to the computational components. So these students or all the audience which actually know the UML, they know the diagram that I use is the UML component diagram, and it helps me to break my problem from a real world problem into different components of the software. So in this project, our partners are University of Southern Queensland in Australia, University of Oulu in Finland, and my institute, which is Lancaster University, Leipzig. So we are currently working on this SE plus IoT problem, which can be applied to smart oceans or try to analyze the underwater data through sensors. Moving on to the next part, the implementation tools and technologies. This slide I just added some people who are more interested in the technological side. So here we can see there are very different kind of tools and technologies. At the sensor layer, we have the sensor, we have Raspberry Pi, we have the CVS files processed through C#. Then it comes to the analytics layer, which have the data store in terms of SQL server. It again have the CSV files, and then is the interface layer. So we can see when you try to research and develop a system, you need multiple type of expertise, front end, back end, but you are not actually the coder or software developer. You need to think, you need to act like an architect that combines these different technologies, and those front end, back end developers would actually take care of it. So the takeaway lessons would be to always keep a bigger picture in mind. If you want to be a good software engineering researcher or a good software engineer, always try to look at the bigger picture. Bigger picture means the system-wide picture, how this system will work. Then the pieces will start to fit in together. So we were able to publish the result in top tier software engineering journal, which is IEEE Transactions on Software Engineering. This is the premier journal in software engineering, and the International Conference on Software Engineering. This is A+ conference in software engineering. This is not just to boost off something, but just to emphasize that when you combine SE with something emerging, something interesting, then the publishable or the publication probability at good venues multiplies. It just becomes much more easier when you try to tackle newer problems with classical software engineering. Next project is on digital health. I'll just give an overview rather than going into too much detail. We are already running quite a short of time. So in this one, we have some sensors and we try to monitor health. And this is like migration to Internet of Things. So we had the old system, which actually the patient needs to go to the doctor to get checkup and everything. We try to automate that. Why not we put the sensors on human body and then try to check all the automated health monitoring. So I'll just try to move to recap and conclusions. This was by no means a very technical, in-depth discussion. It was just to give you an overview that the software engineering you teach at your lectures or labs or wherever you see, it can have a very practical side if you can actually start applying into these emerging domains like IoT or AI or blockchains or quantum computing and all that. So the key takeaways, software engineering for IoT aims to apply the principle and practices of software engineering to develop sensor-driven systems effectively and efficiently. Always remember, the very ultimate goal of software engineering is to deliver a software product effectively and efficiently. Efficiently mean time efficient, cost efficient, and effective mean it effectively does the work it is supposed to do. Focus primarily on the architecture. If you are a software engineer, the best of the best skill that you can ever develop is being a good software architect. If you are a good software architect, you would be like a millionaire working at the right place in no time, because software architects makes the most money. And once you start designing a system, you know why. Context-aware computing can be challenging for software engineering due to resource poverty of IoT and mobile systems, because when you try to compute something, the battery and the processor, they always suffer in IoT systems or devices. So this is where, as an engineer, you will step into develop systems which will be more resource efficient. Future research is aligned towards SE for IoT in the context of blockchains and quantum computing. That's a separate topic that hopefully we would be able to discuss next time. These are some recommended readings. Hopefully, if my screen is not stuck, so you can see here, these are some of the good articles, very easily written, that you can follow up if you are interested in SE plus IoT stuff. We are having a special issue on software engineering for the Internet of Things in an impact factor journal. The link is there. It's by MDPI Electronics. So if you are willing, you are always very welcome to submit to it. So that could be one starting point to work with your publishable, applicable results. This is pretty much it from my side. Let me please complete. This is pretty much it from my side. If you have any questions, you are very welcome, and you can always write to me.
Since we are short of time, thank you very much, Dr. Akash, for the valuable session on the real-world applications of Internet of Things and implementation tools and technologies. To acknowledge the respected speaker, I will request Director UIIT, Professor Dr. Yasir Hafiz, to please come over and present the sheet and certificate. On behalf of Dr. Akash Ahmed, I would like to call Ms. Sabah Nisar to receive the sheet and certificate.
Thank you so much. I would just like to add, needless to say, but once again, Professor Yasser has been my mentor. So it's always a pleasure whenever he calls upon to respond. So this is like more like a personal pleasure.
Thank you very much.
Thank you, sir.
Now I would like to introduce the next speaker, Dr. Shahid Hussain, who has joined us from USA. Dr. Shahid is currently working as an assistant professor at the Computer Science and Software Engineering Department, School of Penn State University, Bahrain, USA. His current research focus is to explore the software engineering practices for high-performance computing, software packages, and applications to improve their process and benchmark their quality levels, automate the document generation for open source software, and to explore the implications of machine learning, artificial intelligence, big data analysis, and soft computing techniques in analysis and design of software. I would request Dr. Shahid Hussain to please start the online session on implications of soft computing techniques for software engineering. Welcome, Dr. Shahid. You can share your screen.
Yes, just 1 minute. Can you see?
Yes, we can see your screen now.
And please check its navigation. It's moving.
Yes, it's moving. You may start now, please. Thank you.
I think it is stuck again.
So we can see the moving screen.
Okay.
It's fine at your end.
Hi, everybody. Good afternoon. My name is Shahid Hussain, and I'm working as assistant professor in Department of Computer Science, Penn State University, USA. And before I start my research talk, I am very thankful to Dr. Qamar Zaman and Dr. Yasser Hafiz who give me opportunity for this to join this nice research collaboration platform. Today, my research talk is related to implication of soft computing technologies for software engineering. And in this research talk, I will present a case study which is related to improve the quality of softwares. Can you see the next slide?
So
Can
now
you see
we can
navigation?
see the moving side. Yeah,
Okay,
we can see the
fine.
navigation.
So this is the layout of my presentation, research talk. And these are some of my expectations that at the end I have expectation that you have some question to me. And okay, let's start our topic. What is soft computing technique? Soft computing technique, actually, it is a group of computation technology, just like neural network, fuzzy logic, and machine learning techniques, which we use to solve its complex problem. And due to its implication, soft computing technologies has been adopted in several domains like finance, transport, inventory management system, and so on. But in the context of software engineering, mostly there are different areas where implication of soft computing technique could be acknowledged, such as software quality, and bugs localization, program comprehensions, requirement prioritization, and improving software design. Since the theme of our today research talk is related to software quality. So my focus in this research talk will be related to software quality. And normally, there are two perspectives to address the quality of a software. One is software refactoring, and another is employment of the software design patterns. In this research talk, I am going to present the implication of software computing for the employment of design patterns, right? And during presentation, if you guys have any question, then please you can stop me and ask question, anyone. So normally, what is a design pattern? Design pattern actually, it is a repeatable solution which a developer find after a frequent occurring of a problem. So when a developer find a problem so many times, then that developer give them a solution, and that solution is called canonical solution. And when that developer record that solution, it is called just like a pattern, right? And normally, if you employ pattern during the design stage, then at the later maintenance stage, your refactoring cost could be reduced. So there is a trade-off between employment of design pattern and reducing the maintenance effort for refactoring. So normally, research community has published a design pattern in different domains like object-oriented development, real-time application, network security, human SCI, fault tolerance, and so on. But these are the common sources, like you can find any pattern, any specific pattern, either from books, article, online libraries, or you have a collaboration with some developers. And if you target on some libraries, recently we got a grant about that how we can organize these pattern on the online libraries, just like this. You can see Rising, EuroPLOP, and Portland patterns, so on. So mostly patterns are published online. So, you know, when patterns are published online other than book, then they don't have any classification scheme. So the major problem has come when you publish your pattern on the online libraries, right? Through this discussion, we can note two important things about pattern. One, that design pattern are published and classified according to developer experience. It means everybody have experience in some solving a problem, then they can publish their patterns, right? And second thing is that we are following the pattern that how we can catalog our pattern. This scheme is published by Alexander, who is the founder that give a template to document our pattern. Just like this, you can see this screen is visible to you. For example, here you can see design pattern have two sections. One is problem domain and another is solution domain. Mostly problem domain is in unstructured format. It means normally it will be text, right? And solution domain depend on that how you are going to present your solution. You are using either class diagram, you are using either source code, you are writing pseudocode, you are using DFD diagram, and so on. So for each problem, you are going to recommend some solution, right? In this case study, we are only targeting on the Gang of 4 design pattern, which are well-known pattern of object-oriented programming language. So 3 other case study are skipped here in this recite task, right? So normally there are 2 sections I have described already, that problem domain and solution domain are 2 important sections of a design pattern. And normally people use 2 approaches, either UML or ontology based. You can see ontology based or UML based. They are taking the leverage, they are leveraging the capabilities of this technique to design an automated tool. But our proposed framework is different from these 2 terminologies like UML and ontology. We are not focusing on this one. We are focusing on the soft computing using machine learning and text categorization approach. So this is the layout of what is design pattern. And you can see here, this is a related work that how existing approaches has been done in the context of pattern organization and pattern selection, software design pattern selection and organization. And for this related work, we perform a partial systematic study and extract some attributes which help us to benchmark the existing techniques. You can see here table. And at the end, if you have question about this table, I will let you know, because due to time shortage, I am going skipping this thing, right? So from literature, we find 3 problems. First problem was related to, you can see the red text here in problem 1, that classification scheme are biased to developer experience. For example, if I am developer, I am working from last 10 years, and I am familiar with one technique or one approach, then I record that approach. I don't consider that other developers are interested in that approach or not. So just I catalog or post that one, right? And anybody who want to learn my approach, they need enough knowledge to understand the pattern. So in case of our case study, we are focusing on Gang of 4 patterns. So Gang of 4 patterns, normally our student, they are learning these patterns during their undergraduate course, software design. But when they go to in market, like when they join industry, they don't have any idea that which type of pattern they have to use, because they need some enough knowledge that how these pattern could be applied, right? So one problem was that to learn the existing technique, existing scheme for software design patterns, any developer, any new designer need enough knowledge. So second problem was related to that on online repositories, there is no classification scheme. In books, you have classification scheme. Any pattern which are published in books, they have classification scheme, but any patterns who are published in online repositories or you can say databases, they don't have any proper classification scheme. So it is difficult for us to find or search any specific pattern from the online repositories, right? So this was second problem. And third problem was related that in the same field, different authors are using or presenting different solution by using different conventions. Like you can see here, I am giving you 3 examples, Gamma, Chord, and Shiv. They are using different approaches to recommend a design pattern in the context of object-oriented development, right? So Gamma are using class diagram, another is like a component or sequence diagram or activity diagram. So every developer has its own solution recommended. So for new designer, it is difficult to learn each developer scheme, right? So third problem was related to that though some existing technique has been introduced, but the issue is that they are context aware. For example, if you design a tool using UML class diagram, or you design a tool using DFD, then that tool only work for a specific pattern catalog. It will not be publicly available for all other type of patterns. So this was the main limitation. Context aware, and you cannot include a new pattern in the existing pattern catalog. So it was also a problem, right? So in order to address these problems, we have set some research objectives, right? So first we have apply a soft computing approach which help us to organize our pattern. Either they are published in books, either they have been published on internet, right? Repositories. And second one is to organize pattern which are published on repository. And third one was related to if you have any design problem or design requirement in text format, then you put that requirement in our framework, and our framework will give you a list of patterns which are more appropriate for your problem. And not only it will give you list of patterns, but it also give you more appropriate pattern for which is highly related or correlated to your design requirement, right? And this is the approach we are going to follow in this context. For example, if you have a design problem, and you have a pattern catalog, and that pattern catalog could become from a book or on an internet library and so on, right? And you have to apply some, in phase 1, you have to apply some pre-processing activities, and then you have to cluster or organize your pattern into groups, and you can see plus sign here. So it shows that our design problem is related to group of these patterns. So in third stage, where we are going for pattern selection, this candidate list and problem will come into third stage. And in third stage, we are applying some similarity measures, which help us to find that which one pattern is more appropriate for our design problem, right? So initially, we have applied this framework in 4 case studies. But these case studies were related to from books. We have created this pattern catalog from books. Nowadays, we apply for a grant, and we granted, university has given us that grant, that we should design this catalog from internet sources, right? So find the problems and solution from internet sources, and then catalog into the repository, online repository. So we are applying also soft computing approaches over there. So you can see how you can formulate your proposed framework. There are 4 stages here: pre-processing, unsupervised learning for design pattern organization, and then identification of appropriate class for our problem. And then we will suggest some patterns at the end. and select a more appropriate pattern. So I am going to skip just giving you a brief overview of these activities. These are pre-processing activities, and later on you can see in my presentation as well. In this diagram, you can see remove stop words, word stemming, indexing, weighting method, and feature selection method. And pre-processing will be done after that. And the next step was unsupervised learning. In this case study, we recommend 4 unsupervised learning techniques like fuzzy, semi, k-mean, agglomerative, and partition around module. We can apply for other one, but still in this case study, we are presenting only this 4 one, right? So next important task was after pattern organization, next thing is to find the pattern class. You know, in Gang of 4, we have 3 pattern classes like creational, behavior, and structural. So our technique will find appropriate pattern class for any problem, right? And at the end, we will recommend, there are several similarity measures you can see here. But the issue is that which one is more appropriate for our proposed framework. So these are the criteria which we have applied, that how we can shortlist any one of similarity measures to include in our framework. So after that, next important thing, whenever you introduce a new framework or new methodology, then you have to introduce an evaluation model for your proposed technique, which is here. But before this, this is the last slide, was proposed method framework. Besides similarity measures, I also recommend some options that how you can rank, or you can shortlist, or you can filter out your patterns. For example, on the basis of these options, you can select more appropriate pattern for your problem, right? So for every proposed method, you should have some evaluation metrics or evaluation model. So in our case, since we have 3 objectives for pattern organization, pattern class determination, and pattern selection, so I have grouped these matrices in accordingly. That one, for example, these matrices are used to find the best weighting method and organization of patterns. And next one was related to that how our unsupervised learning technique are working, like we have recommended adjusted random index, these matrices as well. And this is a description of these performance measure or matrices, that how it will be work in our scheme. And last one was similarity measures. And this is a matrix which we have proposed, like to identify RCD, ratio of correct design patterns. So number of right patterns, suggested design patterns, and total suggested design pattern. So if our scheme give us 10 patterns, and out of 10 patterns, 7 are more appropriate with our design requirement, then its RCD value will be 0.70, right? So this is that how your proposed framework could be functional. So this is the flow chart for that one, that how it could be functional. And this is the case studies. Normally we have performed 4 case studies, but here I am presenting only result of first case study, which is more familiar with our students, graduate and undergraduate student, because they have learned this course, I think software designing, and they know about the Gang of 4 software design patterns, which are mostly employed for object-oriented development, right? So in this case study, we have number of design pattern 23 and number of design classes. All these 23 pattern has been classified into 3 groups. And when we apply pre-processing techniques, then we find 3, 4, 6, 5 number of words. And our sample size that we find the pattern catalog or appropriate pattern for 30 design problems, right? And we have collected these design problems from books and internet resources. A detail is given at the end in references. And what's about our results? In case of gang of 4 design pattern organization, first we applied that which one weighting method is suitable for our unsupervised learners. For example, C-mean, you can see we have applied 5 weighting method. On 5 weighting methods, C-mean is going to outperform with TF-IDF. So in first stage, we recommend that which one weighting method is more appropriate for our unsupervised learner. And you can see the result here. For example, in case of C-mean, TF-IDF is outperformed. Agglomerative is going to outperform with entropy weighting method. Similarly, K-means is going to outperform with like binary weighting method and so on. So after finding best weighting method, now we apply each unsupervised learner with their best weighting method to organize our pattern. And you can see this oval shape. This describes that you are going to cluster 3 clusters. You are making 3 clusters. Why we are making 3 clusters? Because gang of 4 design pattern already have 3 groups. So that is why we want to check or validate the effectiveness of our approach. And in case of 4 cluster, our techniques are not going to perform out well, right? Outperform. So that is show the effectiveness of our soft computing approach, right? And after effectiveness of our approach, next task was related to how our technique is going to find the appropriate class, pattern class. So you can see we have taken sample of 10 design problems, and its description are given on the website as well. So design problem 1, its actual category was behavioral, but our technique ranking it as a behavioral. Okay, so this is a true positive case. Similarly, design problem 2, it's a behavioral, but our technique recommending it as a structural. So this is false positive case for our framework. So how we have computed true positive, false positive, I have shown you already, F-Meyer, precision and recall, etc. And after that, how we can identify through cosine similarity, you can see these are the values for creational and structural and behavioral. And I have underlined those values, for example, structural. So that is why our technique is going to assign structural class for design problem 2. So effectiveness has been computed in this way. And similarly, at the end of our proposed framework, I have shown that we have recommended some options that how we can filter out our patterns. So in case of cosine similarity, argmax, these are appropriate values, right? And similarly, if we consider some thresholds, from that options, so these are the threshold. If your cosine similarity will be in this threshold, so every pattern which will be lie in this threshold will be considered as a candidate for this design problem 1, right? So after that, we have find the RCD value. RCD value remain our high for 10 design problem, because we find corrected patterns for each design problem. And finally, I will conclude it. There are a few major conclusions here. One, that we cannot recommend any weighting method for any unsupervised learner. So this is totally empirical study. So every time when you replicate my experiment with different weighting method and unsupervised learner, then you can find different values, right? So in gang of 4, for example, TF-IDF was the best weighting method for fuzzy C-mean, but it is not necessary that for any Douglas database or any other pattern catalog, TF-IDF could be recommended for all unsupervised learner. So this is one main conclusion. And throughout all unsupervised learning technique, we find that fuzzy C-mean outperform as compared to other one. But it depends on, again, data set characteristic. When data set will be changed, definitely we can recommend fuzzy C-mean throughout all databases, right? So finally, we find we have make a comparison study with the supervised learning technique, and we observed 13.69% increase in the performance in terms of F-MIS to our unsupervised learner, right? So thank you very much. And once again, I'm very thankful to Dr. Qamar Zaman and Dr. Yasir Hafiz to give me opportunity for a nice talk. Thank you. If you have any question, then please. Thank you very much.
Thank you very much, Dr. Shahid, for the informative talk on soft computing techniques for software engineering.
Yes,
To acknowledge the respected speaker, I request Director UIIT, Professor Dr. Yasir Hafiz, to come over and present the shield and certificate. On behalf of Dr. Shahid Hussain, I would like to call Mr. Muhammad Imran Faisal to receive the shield and certificate.
Thank you very much for your valuable talk. Thank you very much. once again.
Thank you very much. Thank you. Have a good day. Bye.
Now I would like to introduce the next speaker, Dr. Imran Sheikh, who has joined us from UK. Dr. Imran is the Director of Software, Roku Limited, subsidiary of Netflix. He does his PhD from the University of Leicester, UK, in the domain of embedded systems. He has 20+ years of experience working with and leading R&D teams for the world's top conglomerates, including General Electric, Northrop Grumman, Alstom, and Honeywell. Now I would request Dr. Imran Sheikh to start the online session on IoT and Industry 4.0, where the opportunities for developing economies.
Assalamu alaikum. Audience, can you hear me?
Yes, we can hear you, sir.
Loud and clear?
Yeah.
Okay, thank you. So, Assalamu alaikum and good evening to the people who are in the halls, labs, and online. I had the opportunity to present to a couple of the students last year, and it was a real pleasure to see the budding engineers and computer scientists and agriculturists to talk with. So today's talk is about IoT and Industry 4. Yes, it's a jargon. It's a very popular term going on around the world, and you probably be listening to it and talking about it. But what is there for us, like for the developing economies, countries like Pakistan? So my talk will be focused mainly in the scenario of developing economies, but giving some examples for Pakistan. I know there are international representatives here, but because I mean it's a very broad topic, and covering that within 25 minutes was like difficult. So I've tried to focus a couple of things. Just introducing my company, I'm working as a director of software engineering for Roku Limited. It's the largest streaming provider, TV service provider in US and Latin America, and it's growing fastly in UK as well. It's in with partnership with Netflix. So basically, I'm leading teams who are working on the TV screens, the programs and all the live TV you are watching on different brands, etc. So yeah, okay. So I mean, interestingly, let's see what is Industry 4. I don't want to go into too many details. of what's Industry 4 and what's IoT is, but it's a disruption. So basically, before Industry 4, we had 3 eras of industry. Industry 1, 2, 3. They had their own periods. When the machines and mechanics was came into being, that was Industry 1. Then mass manufacturing basically revolutionized things to Industry 2. Industry 3 was when internet and web came. And initially when internet came, people thought, okay, it's just like chatting with each other or probably sharing a couple of files. But you have seen, and the previous generations like myself have seen actually how that has revolutionized the world, okay? But now Industry 4 is way above that. Okay, some people think that it's a continuation of Industry 3, but in my opinion, it's not actually. It's very different. It's different in a way. Look at the Ubers of the world. Look at the Airbnbs of the world. Look at the Teslas of the world. Airbnb has got no physical places to rent out to people, but they are the largest outsource providing for accommodation, temporary accommodation to the people. Look at Uber. They're providing taxi services throughout the world without owning a single taxi. Okay, look at Tesla, automation, electric vehicle. It's entirely different. So I would say it's not justified to compare Industry 3 with Industry 4. It's larger. It's very, very much different. And the one keyword, if someone asks me what is Industry 4, I will say disruptive. It has disrupted the norms. It has changed how our lives are and how our lives will be in the next 10 to 20 years. Okay, so let's move ahead. See the next bit. Okay, before I go in and see like how our economy and how Pakistan can take advantage of Industry 4 and IoT, let's see, there is a misconception, and I want to address it. I cannot fully in the given time, but I thought people are thinking that with automation and robotics and AI and all of this stuff, people will start to lose jobs. Did it happen before Industry 1, 2, 3? Yes, for a while. Okay, for a while, people start losing jobs because there were things like that can be done remotely, that can be searched or accessed online when the Industry 3 came. But eventually that has evolved. People have moved on to adapt it, and actually it made a growth in terms of jobs availability and the diversity of things how we can do. Okay, so important thing is that this will be the same thing. I mean, there are a couple of studies, and I think there is a graph with the source of OECD, which is showing that probably in next 5 to 10 years, what sort of sectors will be hit by this cutting of jobs, okay, because of automation. But then on the other side, I would say, don't lose hope. This will transform. So people who are doing manual jobs might be done by robots, but then you need people who need to train these robots, who needs to manufacture these robots, who need to design those jobs, those robots, okay, or any other thing. So just don't lose hope. Yes, this is a very critical time when countries, organizations, and probably at the global level, people have to consider and take it like carefully. Okay, we need to handle it carefully, especially countries like us, that this disruption, what's happening, we need to run along it. We don't want to again lose out as we lost Industry 3. Okay, so this is very important for our economy to be running along. Okay, so I mean, why I picked up this topic was like, if people are known of the UNO SDP 2030 goals, which is basically designed for the whole of the globe, but mainly focusing on developing economies to bring up the disparity in this world between developed and the developing on the underdeveloped. I think developing is just a jargon. It's underdeveloped countries. Basically, they have lack of access to health services, clean water, modern energy services, and so not, and so not. I mean, there are hundreds of things which we lack. Okay, so how basically Industry 4 can come in, because this digital transformation is coming. It's coming into the hand palm. It's coming into your hands. You can do things sitting here while I'm like talking with you guys. How can Industry 4 bring this gap down, and we can achieve these goals? So if we look at developing countries, what are the major challenges to adapting Industry 4? The major challenge is obviously infrastructure. We do not have great infrastructures where we have thousands of sensors and cameras and computer vision devices and RFIDs and blah, 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 okay, installed at nook and corner of our houses or our offices and stuff. So this is a big challenge, okay? Considering IoT, this is a big challenge for us. The another thing is skills. Obviously, I mean, there are so many skills required to adapt it, apart from the infrastructure. Some of the infrastructure of IoT might be cheap, but because we do not have the right skills and understanding, we cannot deliver that. The third thing is obviously investment, and investment comes with interest. Investment is not only lack of money, but it's the lack of the interest of investors, of the people of our country or the developing countries who are actually stuck into conventional technologies and doing things conventionally. Okay, but what are the opportunities? What we have extra, which we can say, okay, let's do it. Okay, and we can do it. We have got educated youth. Still, the percentage is low, but I know people are coming up. Our youth is enthusiastic. They coming into it. They are socially connected and dynamic. It's not like us that we had to physically travel to somewhere to do things or find information. I know when I was writing my thesis, I have to go to library and sit for ages and ages and write. By the way, I'm not too old, but it's only about 20 years old thing. Okay, so I mean, it was like quite a challenge at that time. Even but for you guys, I think it's very straightforward. It's very easy. Even you do not have to go to your university or lecture hall to do these things. So we are very socially connected. I think we have got about 120 million connected users as per my last information in Pakistan. And productivity. We are consumer society. We have got a lot of stuff to consume, as well as we produce a lot of things. Okay, so that means there is opportunity and competitiveness. This is the opportunity to make better products, make use of the technology to make better products, and ensure that we are on track and compete. Okay, so first thing which I'll focus on, I've divided this presentation into couple of different fields to see, okay, where are the opportunities? E-commerce, we have 120 million connected users. I mean, e-commerce and IoT give you enough data to understand shopping behavior, and each locality, each country has got influences from international behaviors and how products and things are made, but the shopping habits are local as well. So IoT devices, sensors, data, all these things can help you determine that and make good products for your local society as well as for exporting outside. Okay, I mean, a great example is Amazon marketing paradigm. I know lot of youth now doing this. And they are selling, they are earning a lot of money, which is like great. I mean, rather than going out for a job, if you can earn that sitting inside your home, this is a very great example. And you would be wondering like, okay, this is just e-commerce, how it's connected with IoT. But imagine the hundreds and thousands of sensor devices in the supply chain, in everywhere where they are installed, which is giving you tracking, which is giving the people who are buying stuff the trust, because they can track and trace, they can know where the product was made, where it was shipped, from where it's coming, and you are handling all of this sitting at your computer. So this is a great opportunity for us developing economies to sell now, because once we have got that marketing hold on and people are trusting us to be actually delivering those products, basically maybe we are buying it from China or any other countries, slowly we can translate this trust into our local manufactured goods, because we are making that trust in terms of selling these products made somewhere else. Okay, so we have a youth potential. We have got handheld devices. We can think about it. We can make it work. Okay, this is a great opportunity for us. See, we cannot make big plants. We cannot invest billions of dollars. We can start from small and medium businesses is the way to go ahead. Okay, and IoT will help you a lot. Think. Next thing, we have always been like, I mean, textile, since I've been born, I've seen textile is our power, textile is our power. But what happened? I mean, we have lost the battle at the moment. I mean, Asian countries, Bangladesh, India, everyone else has taken our business. Yes, maybe there is lack of interest from the government and all these things, but I think technology and not transforming into a digital world is one of the key problems. So, I mean, in one of the talks, Majid Aziz, he's former FEP president, he said about the textile industry, to be digital or not to be digital is not an option. You have to be digital. Okay, digitization, basically what it helps, all these IoT stuff, all these connected devices, all these prediction analysis on your data actually helps you control the inventory, I mean, your supply chain, the crops to storage. Okay, I mean, this is, we lose so much of our cotton crop just because of bad condition and stuff. But this is something which is actually which will help us to actually control. Okay, and there are very smart techniques such as I think I've lost people. Is there any connectivity issue? Can people hear?
I think host has left the meeting or there are some connectivity issues.
Okay. Yeah, I think it's the electricity issue.
So, Dr. Imran Sheikh, you are from?
I'm from UK.
Oh, that's great. Yeah. So I'm, let me introduce myself. I'm Dr. Mohammad Bilal. I'm currently heading software engineering department at FAST Institute, Faisalabad campus, FAST National University.
Excellent to meet you.
Yeah, thank you. I think they have some power issues because all the cameras went down. Let me check with Dr. Mariam, who is hosting the meeting.
Okay. I think there is one, this Peer Meher Ali Shah, or I think there is one.
One admin still connected?
I don't know if it is the admin.
अस्सलाम वालेकुम, डॉक्टर मरियम क्या स्टेटस है? लाइट चली गई है, चलें, we are still waiting. जी मेरे साथ ऑनलाइन ही है डॉक्टर इमरान साहब. Okay, thank you. Yes, electricity issue and they are just reconnecting. So.
There you go. If you had good predictions and analysis, you would find out that
it's trends and
at
behaviors.
this point, electricity would have gone. Yeah.
Yeah, it's 4:30, so we don't need clocks here anymore. So 4:30. Okay. Yeah. So you are for basically I couldn't focus that much because next is my talk. I was just listening in a quick way. Your domain is?
So my domain is software and embedded engineering.
Okay.
Yeah, but I'm giving a talk about, because I'm not from academia. I've been working in industry. So I'm giving a talk about mainly on the Industry 4 relationship, how our economies can take advantage of Industry 4 and IoT. So it's more of a general talk, not academic, and some experiences shared from the industry.
That's really nice that industry people are also linking with academia.
No, I've actually given a talk before in actually it was in person last December, last January at UAR. So it was really fun. The students were quite interested in it. It was basically about blockchain, more of probably technical one. This is more about how we can use things, but yeah.
We have just concluded a conference, IEEE conference, 2 to 3 days back, and most of the guests from Sweden, UK, and other places also visited us. So inshallah, next time I will inshallah contact you, or you can say your visit in the next chapter or somewhere.
Okay.
So I will invite
still
you for
not
our
back?
talk. She said they are connecting, I think. Because they have to run the generators, and almost they will take 5 to 10 minutes, I think.
Okay, fine.
Okay, they can hear our voice. They are going live now.
Okay.
Yeah, they are reconnecting or something like that.
Okay. You have to see where I mean, they lost connectivity. I think I was on the last slide, but I think they're connecting back.
Dr. Imran, can you hear me?
Yes, I can hear you.
Okay, sorry for the interruption. You can continue now.
Okay, I just wanted to make sure that was I on this slide when we disconnected?
Due to shortness of time, you can wind up your presentation.
Okay, yeah. Okay, I can move ahead. So I was explaining something about the textiles. It's our main pain point. Yeah, these are a couple of things people can ask questions about it. I've actually worked on something similar in terms of analytics on GE's General Electric Predict system, which is like digital twins where you can operate a virtual twinage, and that basically gives you all the production, manufacturing, quality, everything in real time, but in a virtual environment, and you can track and trace the production, the maintenance, and everything, which is like an excellent thing for our textile industry to consider going forward. Next thing, okay, I mean, in my last year talk at UAR, I also touched, and I think I went into quite a detail about blockchain and stuff. This is quite an opportunity in terms of IoT industry. For blockchain is not a separate thing. Web 4 is coming. Okay, I think people may be known about it. So blockchain is not only cryptocurrencies. That's what the thing is, that we always thought that, okay, it's about all these Bitcoins and Ethereum and all these stuffs. It's not only about it. Blockchain, I think I don't want to go into the details, but it's a ledger technology which can keep one thing intact, and it is very difficult to forge or change something on it. Okay, millions of devices need to be aligned to make sure. So where it can help us, like ownership and copyright, is something where we struggle either way. So we have been consumers of copyrighted stuff in an illegal way, and also our stuff has been used on the other side of it. Our Himalayan salt has been used with a stamp of somewhere else. Okay, and that's not the right thing. Blockchain technology can actually stop all of this. I just touched about, I mean, we always had an issue with child labor, okay, stamping, that we use child labor, and a lot of our exports in the last couple of decades has been stopped because of these, especially from European Union and USA, etc. This technology, with the use of IoT, can be used to make sure that our manufacturing is child labor free, and we can give a proof, okay, and that can be live. I just touched on the issue of textiles. This technology can also be used to track from the field where a cotton seed is sewed into a field up to the boutique where the clothes are hanged and sold, even without any geographical boundaries. So this is something where we can ponder, and I mean, it's not a very expensive technology. This can be built in, and with the passage of time, the processing and proof of stake sort of things coming in, making it cheaper and less energy consumption is coming in place. So this is something to ponder about. Software exports, like, do we need IoT to have basically increase our software export because we think that if we can write a good program or something, then we are good? No, actually, that's not it. And this is my personal experience, because I deal with a lot of third-party outsourced work where the software contractors are not physically located in EU or in USA, but down in South Asia, okay? So we always try to have one major thing, which is the predictability and traceability. Okay, if we can predict and if we can trace what the work is being done and what's the quality of the work is, it always gives us that trust to give them more business. And that's where we are lying as well. As a Pakistani industry is growing, I know the target is $3 billion for the next year, but IoT can bring up that trust with the sort of tracking and delivery. And it's not only that always the sensors are involved, like we have got very smart dashboards. I mean, Roku I work for, which is linked to Gits and Jiras. So any work anyone is doing without monitoring them physically, without monitoring them with a camera, you can actually see what they are doing, what they're delivering, their quality, their testing matrix, and everything is enormous, and it can be shown live, and you can see what's happening around. I think this is a very big area. And another thing which I wanted to highlight is that we are doing a lot of software exports. We have IT $3 billion contribution. What is our contribution to the IoT domain? Are we exporting any IoT software? Yes, we cannot manufacture complex processing chips and stuff. We're not yet there, but can we make good IoT software? I know some people are doing it, but it's not at a mass level. Okay, healthcare. Some people who are senior like me can remember a Lady Health program, okay, where ladies, used to go to villages and provide all these polio vaccination. Women who were pregnant, they used to take care of them, and they had to do all these visits. Can IoT solve these problems? You have got smartwatches, you have got smartphones, you have got simple sensor devices to actually cater for all of these things. Okay, they can give you live data, live Bluetooth information, wireless information, your sensors are connected to your body, etc., and they are cheap. They're coming down. The prices are coming down. Remote doctors and healthcare. We cannot. Most of our population cannot afford free healthcare. Paid healthcare. They cannot go into it. So I think this is an area where we can reach out to far-flung areas, as well as we can use technology to basically get cheap healthcare. Okay.
Sorry for the interruption, sir. Can you please wind up your presentation? We are lack of time.
Okay, yeah, that's fine. So I had a couple of other things, but yes, lack of time and because of the electricity interruption, I would like to keep 1 or 2 slides at the last, because you guys are related to academics. This is very important, where IoT can come in. For like poorer economies, reach of good education is a problem. Time and space is a limitation. IoT can fill that up. Okay, we can have remote access, and in our economy, like children, sometimes they have to support their families. So not only the space, where if there are good schools or not, they also have the time limitation. So morning classes, etc., they cannot attend. This is something which can help us. And even in our modern education, in our universities, we can use like a lot of data analytics. We can provide people with interest-based learning, where we are calling it makers. So makers are people who can do things, who can achieve things. They're not limited to passing certain set questions and passing exams. They can do things. They can really make stuff. So final thing, okay, where I want to emphasize and where I want to, share my experiences and probably some suggestions to the academic initiatives. They can play an excellent role. Please think out of the box. Can funding be used to address more local problems? Yes, we need to do a lot of research for the sake of research, for doing a lot of printing of papers and publishing, but can they be objective? Can they solve local problems? I always use this word, and I think it's taken from one of my presentation before. Don't waste your hard work gathering dust on bookshelves, okay? I think you got the point that yes, we can publish in a journal with high accreditations. Yes, yeah. So the last thing is entrepreneurs and not employees. That's what we need. That's probably it. Yeah. Thank you. I would like to stop.
Thank you very much, Dr. Imran, for sharing the valuable information. To acknowledge the starter speaker, I request Director UIIT, Professor Dr. Yasir Hafiz, to please come over and present the shield. On behalf of Dr. Imran Sheikh, I would call Mr. Fraz Bibi to receive the shield and certificate. Now I would like to introduce the next guest speaker, Dr. Muhammad Bilal. Dr. Bilal is an assistant professor and in charge at the Department of Software Engineering, FAST National University of Computer and Emerging Sciences. He did his PhD from Pillars University, Malaysia, and has published several research articles in well-reputed journals and conferences. His research interests include data mining, social computing, machine learning, information processing, social media, data analytics, and software engineering. I would request Dr. Muhammad Bilal to please start the online session on the rise of social media analytics and machine learning. You may start, Dr. Bilal. We can see your screen.
Okay, can you hear me?
Yes, we can hear you.
Okay, thank you. So due to the shortage of time, let me start. Okay, first of all, thank you, Dr. Mariam, for a brief introduction of me. And firstly, I would like to thank Professor Dr. Kamaruzzaman, Vice Chancellor, and Professor Dr. Yasir Hafiz, Director UIIT, for inviting me to give a guest talk. So the topic which I'm going to talk about is the rise of social media analytics and machine learning. As we all know, we are using social media on a daily basis, but we are certainly doing something intentionally, and so we are certainly doing something unintentionally. We are posting and a huge amount of publicly available data, our private data as well. So this was the main motivation of my research. My main domain is actually social media data analytics. I used to play with social media data in terms of user reviews, user feedbacks, user posts, and try to predict and come up with some interesting patterns from the data. So the contents of my talk, can you see this next slide? Okay, yeah, it's working now. So the contents of my presentation will include the current landscape of social media, the characteristics of social media data. Basically, as I'm talking about social media, we are talking about data mining, pattern mining, and machine learning. We will be talking about the use of social media data. So we should know about its characteristics before we are going to use it. So if we know about a thing better beforehand, we can handle it more, you can say, accurately. Then there are some certain challenges that are also associated with social media data that we have to look into, and we will have to take care of those particular challenges that we can face during the use of social media data for certain purposes. Then I will just quickly give an overview of basic process of KDD and social media analytics, because knowledge discovery and databases is actually similar to the data mining term, but it's a fancy term, social media mining, because we are using social media data. So it's relatable. And lastly, I will give you some applications which I have done in my previous researches, and as I will give a quick overview of recent trends and application domains in which social media analytics can be used in various ways. So firstly, to start with, you can say, some questions. So how do you think you use Facebook? From user perspective, if I am a user, I can see that I'm using Facebook to connect with friends. Then where do you think Facebook can be used? Okay, Facebook can be used for collaboration and for interaction, to join, you can say, previous friends, to join your alumni and join your related groups. And what about the Yelp, Amazon, and other Twitter and other social media websites like these? So these are some of the things that are from the user perspective. And when we change the side of the table, and when we go to the other side, we can ask the other questions as well. How does Facebook use your data? Actually, if we talk about the social media websites, it will be like that you are the product of social media. They are not taking any penny from you to use social media. So what's inside that? They are giving you free services to use social media. So are they so much kind, or there is something else. Actually, you are the product of them. Your data is the product of them. They sell you actually to their some other customers for their particular recommendations and other purposes. Then what about Yelp, Amazon, and Twitter? What do you think how your data is being used? Your data is being used, for example, by Yelp. If we talk about the Yelp rate businesses, different businesses, customer post reviews about the different businesses. So Yelp provide businesses the services to improve their ranking, Yelp ranking. So Yelp use your data, the user generated content that user post about different businesses and encourages businesses and provide services to the businesses to come up with certain solutions that will help them to improve their ranking. That's one of the you can say example of Yelp selling you. So social media data is social media is so fast, so vast. It's just like an ocean, and we are trying to you can say put up into a small container to define it. But yes, we can define a little bit. So social media formal definition for it can be is the use of electronic and internet tools for the purpose of sharing and discussing information and experience with other human beings in some efficient ways. So first we have to clear thoughts about the social media. Social media websites are actually not only you can say Facebook, Twitter, LinkedIn. Yes, opinion and reviews websites are there. That are also a type of social media platform. Social news websites are there. Entertainment websites are there. Messaging platforms are there. So there are huge categories and that are involved in the landscape of social media. One of the interesting paper about social media before and after 2010. So there is a one paper, 25 years of social media, that try to, you can say, analyze the definition of social media and its applications in from 1994 to 2021 in 2019. This paper is published in Cyber Psychology, Behavior and Social Networking in 2021. So it says that social media landscape, if we see social media, Facebook starts in 2009. And if we compare the social landscape of social media, the applications available at that time and the applications available now, we can see a huge increase in the numbers. And even some applications are not being used right now. They are deprecated, or due to certain reason, they are being, you can say, shifted we can see the shift. For example, previously I used Facebook, I moved to Twitter for certain purposes, or I can move to the LinkedIn. So we can see the shift, or we can see that some applications are closed, like Google Plus. We cannot see that as much now. It was formally announced as closed. So some elements of, for example, the facts as social media connects people are common. The definitions are rather different from each other. For example, if we are talking about the social media platform, for example, social media platform, Facebook is a social media platform, LinkedIn is a social media platform, YouTube is a social media platform. So all of these have some common characteristics, and all of these have some different characteristics. So we have to see the commonalities and see the differences. So to categorize these medias, based on it, we draw its landscape. In the next few slides, we will see the landscape of social media. But basically, if we talk about the definition, so the authors saw that there are two main streams of definition. We can come up with the definitions that are published before 2010, and then there is a school of thought that come up with some definitions that are categorized after 2010. So before 2010, SM social media was commonly, you can say, approached as a tool for connectivity for people with common interests. So it is seen as a tool for connectivity. And after 2010, it was seen as a tool for creating and sharing user-generated content. So totally, you can say the perspective is different before 2010, and after 2010, it's totally different. So this is a social media landscape. You can say in 2015, it was the applications are like that. And when you see this landscape in 2020, it becomes something like this. So previously there are no collaborating websites, and then there's a certain region appear that holds some, you can say, collaboration related website as well. So let's talk about the 1 internet minute. So we are talking about whenever we start some research or anything, we talk about where is data coming from, is data available or not, can we get the data. So these are some stats that can you can say give you a motivation to use social media data or go towards the social media analytics. And there is also saying that the data is the next fuel for the nations, and data science, that's why data science and other business analytics programs emerge. So you can see the comparison that it's the rise, the volume of data continuously increase over the internet. So you can see all these stats there for later you can review. I cannot, I can go, but it will take some time, so I will just skip that. These are some other stats based on the number of users, mostly monthly active users. Facebook, yes, even you can say if I see my 24 hours and I have a Facebook app, I mostly usually when I'm free, I scroll Facebook. So you can see these stats maybe because of that. We use this is the mostly active, so the mostly active users, and then YouTube, and then WhatsApp, and then Messenger, and so on. The other websites are there as well. And then if we talk about the social media and the, you can say audience, number of, you can say based on the population, if we say the what's the population of the world and what's the number of being user. So we can say that it's by the Statista that 38% of the world population is on social media. They are using social media. So half of 1/3 of the globe is on social media now. So main characteristics about these social media platforms are participation, like for example, if I'm talking about any other medium or platform that does not encourage participation. For example, if I post something, any other you can say user can comment, can forward, can contribute in any way. So we can participate in that particular debate. It's not a one-way medium that you are a listener and you cannot you can say reply to that. So it's not. So it's a characteristics of social media that you can participate in anything going on. It's openness property. Yeah, you can put and paste. You can say any feedback, anything. For example, you can review a business positively, review a business negatively, say different comments about different things. Even you can say. Like in Pakistan, most of the you can say political parties, they use social media platforms against each other. So no one is you can say stopped by the other. So all are using. So it's open as of this concern. Then for the conversation, yes, we have a traditional media. If we talk about the televisions and other stuff that broadcast, that's only one-way communication. But here we are talking about the two-way communication. Even if someone posts something, we can reply back and coordinate. Yes, and the next one is community. If we talk about the community thing, yes, like we are sitting here attending this first international workshop. So this is a community of people that have a common interest in attending this event. Likewise, you created your WhatsApp groups, you created your Facebook groups, Facebook pages, the similar interest people like. So it forms a sense of community, bring together the people that have related interests. And lastly, connectedness. So most of the social media thrive on their connectedness, making use the links to the other sites and resources and people, etc. Like you can say Facebook and Instagram are connected, WhatsApp are connected. Most of the things are owned by Meta now, so they are connected. Now comes toward the challenges. If we talk about the first big challenge is big data paradox. So we are talking, we have seen some stats of 1 minute, but social media data is big. Yes, it's big, but it's not evenly distributed. For one thing, we have millions of data. For example, if I'm talking about, you can say the presence of people on the social media, and I am using it for a certain purpose. Maybe for me, if I'm a frequent user of social media, you can get a huge amount of data about me, and there is a one user just logged in and he is not an active user, you might get a very little information about that particular person from the social media. The second main challenge is obtaining sufficient samples. Yes, are your samples reliable, representative of the full data? Yes, you can relate it to the first one. And then noise removal flawlessly. So too much removal makes more sparse. Okay, so we have a data and we try to make it more accurate by using reducing the noise. It may get the more sparse. So we have to carefully see how we are going to remove you can say instances from our data sets. So noise definition is relative or complicated and task dependent in social media. So we cannot say that the common you can say noise removal techniques are being used on the social media. No, it's dependent on the task, what task you are doing. So it depends, it may change from the previous practices. And then lastly, evaluation dilemma. So where there is no ground truth, so how we can evaluate? So it's a problem that you have to come up with some ground truth like the other things. And there are some, you can say baseline things. There is some ground truth available that you can evaluate. So in social media, having a ground truth is not that much easy. So these are some of the challenges. Now quickly coming toward the knowledge discovery and databases. From databases, KDD is a process that mostly you can say transform the raw data into knowledge. But here you can see what about the social media mining or social media analytics process? It's the same, but the input changes where we are talking about the data. The nature of data becomes social media data. So all the remaining process same, and each phase has so it's specific steps. Like we can talk about the quality of data, what transformation techniques are being used, how it is being pre-processed. So I'm not going into that detail due to the time, you can say constraint. So let's move forward. So if we talk about the data mining, so data mining is the process of discovering hidden actionable patterns from the data. And when we talk about the social media mining or analytics, it's the same process, but based on the social media data.
Sir, thank you so much.
I think it's, let me take few more minutes. It's more meaningful than otherwise. Yeah. Otherwise, you can say the main things, I'm expecting that the students are masters or PhD. So hopefully they can get something for their future perspective. So just give me 5 minutes, I will wind up hopefully. So these are the machine learning techniques from the machine learning perspective. So yes, social media data is there, but what you are going to do, either you are doing a classification task, either you are performing a regression task, or you are going to use some, you can say unsupervised clustering algorithms or any other. So these are some of the machine learning techniques. There is a huge debate on it, which techniques are being used. So I'm just skipping that. You can see the examples there in the classification, spam detection is there. And lastly, for the unsupervised, like community detection, etc. There is also a technique, for example, social media data is there, and social media, you can see the users as you can say nodes and the connections, for example, me and my friend, we are friends on Facebook. So we are two nodes and there is a connectivity, there is a link between us. So that can be considered as a tie. So it is a, you can say, use of networks and graph theory to come up with some social structures to analyze the data. So social network analysis is another technique, machine learning. And other than that, we can use social media data. These are some of the examples. I will not talk about that. Let me come to some other examples. So these are from here the application starts. So social profiling is one application of you can say social media analytics, and there is a huge category of you can say tasks you can done. For example, you can analyze the emotion, behavior of user. You can analyze the personality. So this is the taxonomy of social media. Social profiling. So we can talk about from this user perspective, we can talk about from the group perspective, and then we can classify the characteristics based on demographics, psychographics, and wellness. So this is all about the one perspective of social media analytics. So we can talk about the social profiling thing. Then there is a business profiling. For example, this is an example of using Yelp data. We analyzed that some businesses have a stable start and some businesses have an unstable start, and how it impacts their performance in the later years. Similarly, for the reviewer profiling, we see how reviewer rate the different businesses. So there are some regular behavior and there are some irregular behaviors that deviates from their patterns. So these are a few examples of that. Lastly, the most interesting one, I want to go with this example. This is about the profiling political influence using social media. So let's talk about the local context of Pakistan. So about the 2018 general elections, most of the social media political parties uses social media platform to influence the individuals. So I scrapped the data about these parties. So general public is there, political parties there. Here you can see I only took 3 political parties, PMLN, PTI, and PPP. So I took these 3 parties because of their presence on social media. Even some political parties are not that much, you can say, active on social media. So this is one of the limitations I talked about in the previous slides. So they are all present on social media. They infected so I used Facebook posts, and then I extracted their post reactions, and then post reactions are collected and perform the analysis, and then I propose standing deviation model and Bayesian networks and come up with the results to predict the seeds one. So based on this paper, one of the, you can say, the sitting ministers also contacted me on this. So that I'm still working on this or not. So these are some stats about the data, and you can see I'm quickly coming to the results, so you can see the patterns. So if we talk about the 3 parties, that PMLN is you can say shown in red, blue, and red. PTI is in blue and PP in green color. So you can see the difference between the posting behaviors. So language, you can see the PTI used mostly the Urdu language, PMLN. PTI use the English language mostly and or mostly equal. And these are the, you can say, type of feeds. Either they use you can say photos, videos, or links or something. These are the interesting thing, that all these pages have some information. You can see the shares, compare the shares of the, you can say, this PTI with the other 2 political parties. You can see it's in, you can say, millions,
Sir,
but
can
it
you
is in
please
only.
wind up your presentation as we are short of time?
Oh yes, I'm going to wind up. Just give me 2 minutes. So after this, using some standing deviation model, I've come up with this course, and you can see the bars. So it predicted like this: 116 seats, 64, and 63. These are the actual results from the Election Commission of Pakistan, and this is the you can say influence score predicted. And from that we can see that only we have a small difference of minus 4.95%, 2 and 3, 2.31%. So lastly, these are some of the areas. So these are some only you can say, these are only areas. So I'm not talking about this. The highlighted one I have worked on, but the rest of the one, a lot of things can be done using social media. So I think due to the, you can say,
thank you very much,
not
sir,
that much time, so questions cannot be taken. Okay.
Due to shortage of time, to acknowledge the respected speaker, I request Director UIIT Professor Dr. Yasir Hafiz to come over and present the shield and certificate. On behalf of Dr. Mohammed Bilal, I would like to call Dr. Kashif Sattar to receive the shield and certificate.
I would like to be in session. If it will be, you can say, next time be in person, it will be a very interesting topic to talk on.
Thank you so much, sir.
Yeah, thank you.
So I would like to introduce our next speaker, Dr. Wendy Wang, who has joined us from USC. Dr. Wang is an associate professor of computer science and software engineering at Penn State, Maryland, USC. Dr. Wang's first engineering job was as a land administrator for the Department of MIS in Taiwan. He then worked as a graduate teaching assistant while completing his education at SUNY Albany. Dr. Deng is a member of the Institute of Electrical and Electronic Engineering. Now I would request Dr. Melanie Wang, please start the online session on comparison of two types of learning approaches on practically and performance in solving the Kokoro puzzle.
Thank you. Thank you. It's an honor to be able to give a talk here. And maybe should say good afternoon, even though here is pretty early. So I would like to just get started. I hope that everybody can hear me clearly. Basically, it's a motivation to do a work on like optimization problem and using learning approaches. And traditionally, when we try to solve problems, and even a problem has an optimal solution, a lot of learning approaches can only give you very close to the optimal result. It's really difficult to find the optimal solution. So for that kind of reason, we are interested in finding a way to see can it be feasible to take advantage of some kind of learning approaches to actually find the optimal solution. So for the title, you can see like the Kakuro puzzle is actually an NP-hard problem, and it has always like one single solution. And how to find a solution for such a hard problem is actually quite challenging. And that's basically what the talk is about. Okay. So I'm going to give a very, basically a simple agenda. First, give an introduction about what Kakuro puzzle is, and simply just list out a bunch of learning approaches that can be utilized. And then mainly focus on two approaches that we took advantage and trying to solve the problem, and show you the pros and cons about those kind of approaches. And hopefully I can give you a demo about the performance and let you understand why this kind of problem can be difficult, and finally give a conclusion. So what is a Kakuro puzzle? It's actually quite similar to the crossword puzzle that we sometimes can see in newspaper. And as you can see, basically every single column and row, the same character can be used by a column and a row. And it has a lot of coupling, and that's something that can be really troublesome, because somehow when we happen to use another character, then it will happen to have a different result, but it may not come out with the final solution. So what Kakuro is it's not using letters, because of course word is using letters, but for Kakuro it's using numbers. So here is actually a Kakuro puzzle, very simple one. And you can see that in the background, I put down a lot of numbers because those are the numbers that we can put in. So basically for every single cell, it can only go from 1 up to 9. So every single cell can be 1 or 2 or 9. And the key thing is the sum has to be the same as the number assigned. So for here, it shows 4. And it means that these two cells, the sum has to be 4. And the other constraint is they cannot have any duplicate. So we cannot have 2 and 2. Instead, we can only have like 1 and 3 or 3 and 1. So something like that. And we have to be able to solve such kind of a puzzle in a very short time. And I will try to explain why this kind of puzzle is useful in reality. So here is a solution. It's not calculated, simply just paste it on, but later we will have demo to show how to do it. So if we take a look at this, in reality, it's really quite useful because it's like solving a linear programming problem. And we like to know what kind of result when we happen to have a linear programming problem. So for example, if every single cell, every single white cell is treated as a variable, then now we can say that like say this one is x1 and this is x2. So then we say x1 plus x2 equal to 4. And then on the other hand, for 7, it would become x1 plus maybe x5, x9 equal to 7. So we have so many variables, and then put in all of those variables together and have them yield certain type of sum result, and then we try to solve it. And we are hoping that the final result can be calculated correctly and also very quickly. And that's kind of like the idea. So there are some kind of challenges that we are facing. Basically, it's an NP-hard problem, meaning that we cannot get it done in, like say, polynomial time. And every single cell simply just connect to a row and also a sum is a high coupling issue, and they interlock each other pretty strongly. And it is also just one single solution. And that's actually a very challenging issue. So if we get to think about what kind of ways that we can solve. Previously, I said it's NP-hard, it's non-polynomial time. So if we think about there are 100 cells, and each cell can go from 1 to 9. Ideally, the possibility to find out a solution is like, basically the possible options is 100 to the power of 9, and that's really a big number. So it takes forever to really come up with a solution for just a small puzzle. And a lot of puzzle has like more than 1,000 cells, so it will take forever. So the learning approaches that can be probably utilized to solve this kind of problem. Of course, AI is useful. We cannot think about doing like search, depth first or breadth first search. That's commonly used, but it still takes forever because one number, once we understand the number, then we utilize the number to search the other one. And when there is a conflict, then we simply just jump back. So it's not a really ideal situation. And then for the machine learning, yeah, we can take advantage of even deep learning, supervised learning, or unsupervised learning, or support vector machine decision trees, those type of approaches to do so. Unfortunately, after we apply those, it's really similar like the traditional situation. Like, yeah, you can kind of find out a close solution, but it's really hard to find the final solution. So there are also other ways, like in reinforcement learning, try to find pattern and take advantage of the pattern to find a better solution. Unfortunately, yeah, it still takes a long time because the pattern just keep changing, and we never know whether the pattern is really the right pattern or not. So the last two are the approaches that I actually like to introduce to everyone. One is called evolutionary programming, and it's actually widely used already, like simulated annealing, genetic algorithm, and or swarm intelligence. I'm going to focus on swarm intelligence using ant colony to show you how the problem can be solved. And there's another one which happens to be quite efficient. We call it iterative scans. And we basically try to scan through the cells and hoping that we can identify some result for the cells. And then later on can take advantage of the knowledge to keep going to find, like say the values for the other cells. So these are the basically two solvers. One is evolutionary. The other one is the iterative scan. So this kind of research is a little bit different from like the research that most people do here, using data sets and trying to identify some kind of relationships. Instead, this is more like try to see that if we can optimize some kind of try to find an optimal solution for certain type of situations, and trying to make sure that the precision can be as high as possible. That would be simply just quite nice. So for the swarm intelligence, the idea is based on something called ant colony. So basically, we are saying that a bunch of ants, if they can work together, even though they are not very smart, they can form some kind of a smartness, and it becomes like intelligence that we can take advantage. So I try to explain it based on the right-hand side diagram. So basically, you can see that there are some dots, two dots, that's actually three green. Those are food. I should probably use a different kind of notation. So green are food, and ants trying to find those food, and they want to bring it back to the ant hill. That's the red dot. So all of the other dots, like the blue dots and the gray dots, are ants, and there is a distinction between them. Blue dots meaning that they already grabbed some food and try to bring it back to the ant hill. For the gray dots, they are still trying to go out and find food. So ants utilize some kind of a simple approach called pheromone. So they simply just try to put down a pheromone if they happen to find food, or if they find their own ant hill, so that they can notify the other ants to simply just either go get food or come back to the ant hill. The funny thing is the pheromone, the scent, can also dissipate, because after a while, if no more food exists, then the scent is supposed to simply just go away. And if nobody really, no ants surrounding the ant hill, then the scent should also go away as well. So those kind of a pheromone forms some kind of pattern to help the ants to know what to do next. And the ants basically simply just try to take advantage of those kind of patterns and trying to help each other. And then finally, they can grab all of the food back to their ant hill. And these kind of results is always based on the objective functions, because they work together. And then each one can get different kind of result. And then we will try to take advantage of, like say, the best end result and utilize that result to simply just find the better solution for the next time. So the pattern will change, and the ends will simply just take advantage of those kind of information and just keep going. So let's move on. So how do we utilize those? Basically, a bunch of ants go out and then thinking about an ant trying to put in some numbers and feed in numbers into those kind of empty cells. And you can see that I highlighted some of them. An ant initially may not be smart enough. They can come up with a duplicate result like 7, 7 and 4, 4. I say that are not duplication. And here I even highlighted 5. It's not a duplicate, but we can see that the raw sum is 11, is more than 10. So the other end will also try to get a solution similar like this, but it can be worse. And maybe some can find a better solution. Then we will take advantage of that better solution as using it as a pattern to find even better solution. So that's the learning approach the ants trying to use. So if we look at the final result, ideally, there should be no duplication, and the sum should be exactly correct. Like say 7, it should be 1 plus 2 plus 4. But initially, it has some conflicts, and we will take advantage of the number of conflicts and try to reduce the number of conflicts and try to find the result. So that's the idea of ant colony, and using that to find solution. The iterative approach is somehow different, and it's based on gradient descent. And most of the learning approaches are based on gradient descent, but this one significantly rely on this kind of concept. So if we take a look at this, we can see that here I put down vertical room. What it means is each one is a cell, and each column here is a room. So here is another room. So for basically a small section of horizontal cells connecting together forms a room, or vertical. So if we come back, we see that first we try to scan every single room, and then we dig into individual cell and trying to see any kind of information between the intersected portion, because each cell is an intersection between horizontal room and the vertical room. And we can take advantage of the number, use it as the constraint to help us identify probably the correct value, and then simply just try to shrink the range, and then eventually we can find the result. So after we scan the vertical room, and the result will be utilized for us to scan the horizontal room. And if we happen to find better result, then we can continue to do so, and then hoping that the entire puzzle can be solved. So let's take a look at this one for illustration. So the room that I want to illustrate will be this one, since we have limited time. So I'm going to simply just focus on this part. So here the sum should be 4. For 4, it can only be 1 plus 3. So meaning that the range can only be 1 to 3 and 1 to 3. Then for this 7, it can be 1 to 4. So ideally it should be 1 to 4, 1 to 4, and 1 to 4. But since previously I say it's 1 to 3, and the other one is 1 to 4, then we know that it can only go from 1 to 3. Similarly, this one can only go from 1 to 3 because the 6 can only be 1, 2, 3. And so by doing so, we understand this can be 1 to 4. Then the answer is out because this can only be 1 to 3, this 1 to 3, this one is 1 to 4. The only one that can be 4 is this cell. So then we are able to identify the value is 4. The fun part about this is, or like saying the most significant portion of this is the 4 is a set value. We definitely know that the value is 4, but previously when we were using the approach like swarm intelligence, we actually don't know which value is set. They are very close, but we cannot be sure that they are set already. So I'm going to do a quick demo so that everyone has a feeling about it, and then we can dig into the practicality and the performance part by actually seeing the demo. So sorry about that. Let me just do a quick. I hope that it is visible. So for here, this one is based on swarm intelligence. And the right-hand side is actually based on the iterative scan. And we want to know whether, like say, do some kind of a comparison. So if I do the swarm intelligence, it will start to do a lot of number changes because it's kind of like a constantly learning. So it will start to change, and then maybe after a second or two, the result is found. So it will stabilize. On the right-hand side, we are doing those kind of scanning, and we expect to be much faster result. So like say solve, and it will come out kind of instantly because of some of the values. Once we find the result, we know that it's a set value, and with that kind of a result, then we can just keep going to do more. Unfortunately, on the left-hand side, it has some kind of limitations. Even though it can solve the problem, when the puzzle becomes bigger, it takes a long time. You will start to have a lot of conflicts because the conflicts can be reduced. And then after the numbers are gradually reduced, we cannot be sure every single cell is actually the correct result. But on the right-hand side, let me just pull it down a little bit. I'm going to run the same puzzle and trying to show you, we can solve it immediately. The left-hand side is still spending a lot of time trying to find a suitable solution. If I try to open up a very big puzzle, like 100 by 100, that's huge. It has so many cells inside it, and we are still expecting to solve these much faster. So let's say I click on solve, and hopefully after just a few seconds, we can see the result to be solved. So traditionally, if we utilize a lot of learning approaches, this is really not solvable. It's just taking forever to solve. By utilizing the other way, then it becomes feasible. But it doesn't mean that this kind of approach has no limitation. It actually has some limitations because if we do scan and we cannot find any improvements, then it will hang there, then it cannot proceed. So then it becomes important to have some kind of a guessing abilities to put in and being able to find a solution. So I'm hoping that I can find something to quickly show you. So if we happen to have puzzle like this, sometimes the first phase we can only find some of the cells. And it means that we can no longer find any more cells. How do we continue to move on? Then we have to start to do some kind of guessing. And if we can guess nicely, then after we finding some kind of conflicts, then we can also get the results out. And it's still quite good in performance. So let me get back to the slides and finalize it. So overall, the comparison between the two, the practicality-wise, evolutionary programming is actually kind of nice in certain type of ways because it has random values being utilized. We do guessing all the time, so guessing is really easy, no problem. But unfortunately, it's only good for small size puzzle. As you can see, small size puzzle is really no problem, and we can find a result also in decent speed. And the good thing about this is it's actually quite good to adapt to frequent environmental changes. The puzzle is actually not a changing environment, but in real world, there are a lot of environments that's not stable. It can simply just change all the time. So the pattern can actually help accommodate those kind of changes. On the other hand, for the iterative scan, it's actually good for basically making improvements because the found values are already set. Random is not really utilized. Guessing sometimes can be much more complicated. The one that I show you happens to be easy. It can also take a long time for certain type of puzzle. Then it's actually quite good for large size puzzles. So it's very useful for reality. So if one day we have a similar, like say, big linear programming problems, then we can take advantage of this kind of approach to find solution. And then, of course, it's harder to adapt to environmental changes. Performance-wise, I already showed you, unfortunately, evolutionary programming is really not that great. And you see that for 10 by 12 size, it takes somehow up to 5 seconds to solve it. But then for the iterative scan, like 100 by 100, in a lot of situations, we can solve in 2 seconds. Then the other thing is the iterative scan, the performance is quite stable. Every single time you try to run it, it's almost about the same time for the evolutionary because it's based on a lot of guessing. Then yeah, it's not quite constant. So I would like to basically conclude the talk. So here I try to utilize Kakuro puzzle as an example to show that the NP-hard problems are actually hard to be solved, especially when there is only one solution, meaning that's an optimal solution. And most of the learning approaches have some difficulty finding the only one solution. They can find very close solutions. So how do we really try to find the optimal solution? That becomes a challenge. And then there are so many types of learning approaches, and try to show that different approaches have different kind of usages. If we are more interested in changing environments, evolutionary programming can be quite useful. And for other approaches, other learning approaches, sometimes they are able to adapt to the changing environment as well. So evolutionary incorporates random values so it can adapt to those change, but iterative scan, it can achieve pretty good performance. And if we can actually try to figure out how to do good learning, yeah, it becomes really quite efficient. So the final line is it possible to maybe say come up with a hybrid approach? Yes, we have some publications about a hybrid approach, basically trying to combine the two for different kind of situations. Maybe sometimes when there are some uncertainties, the evolutionary can help a lot. When there are a lot of certainties, iterative scan is definitely more useful. So thank you, and I hope that it's different, but I hope it has some benefits to the audience.
Thank you very much, Dr. Wendy Wong, for sharing the valuable information about solving the Kaguro puzzle. Now, to acknowledge the respected speaker, I would like to request Director UIIT, Professor Dr. Yasir Hafiz, to please come and present the sheet and certificate.
Yeah, thank you. Thank you very much.
On behalf of Dr. Wendy Wong, I would like to call Dr. Muhammad Aqib to receive the shield and certificate.
Thank you.
Thank you very much, sir.
Yeah, thank you.
Thank you, Dr. Wendy.
Yeah, thank you. Thank you.
Now, I would like to introduce the next keynote speaker, Dr. Nurzaman Janji, who has joined us from Malaysia. Dr. Nurzaman is currently working as an associate professor and director, Center for Smart Society 5.0, and cluster head for cybersecurity research cluster at the School of Computer Science and Engineering, Taylor's University, Malaysia. He has 22 years of teaching, research, and administrative experience internationally. Dr. Zaman serves as associate editor and editorial advisory board for several reputable journals, including IEEE Access, PCNever for several conferences, and guest editor. He has several patents, edited, authored more than 30 research books. He has completed more than 20 funded research grants, served as keynote speaker for several conferences, and presented several webinars, chaired and co-chaired international conferences. Now I would request Dr. Nurzaman to please start the online session on cybersecurity, current challenges to the society.
Thank you. Thank you very much, Dr. Mariam, for the introduction. Please just let me confirm my screen is visible.
No, sir, your screen is not visible yet.
Is it now?
Yes, sir, it's visible now.
Okay. Thank you. Thank you very much once again. Thank you very much to the organization committee for providing this opportunity. We are aware that we have very limited amount of time, and we will try to manage within this time. So our focus today is about the cybersecurity current challenges, that what they are for the society, especially. I mean, myself, Dr. Nurzaman, is with you. We can skip this introduction and the other parts that could be discussed later on. Here are the links provided in case for our research center, Research Excellence Center, where we do have the collaborations with more than the 60 different international countries and industries. So we welcome to all of the research collaborations. And here are the few of the books which are recently edited and authored by myself out of those 40 books. So now we're coming towards the point. The point is actually that we all are aware about the cybersecurity issues and challenges. No one can deny from this one. And this is a huge challenge nowadays. So at this stage, we need to understand first a quick understanding that what is actually the attacks and what are those crimes, like what we can call, that is actually the crime where the people they involve illegally using the internet. And when the computer is the target and computer itself is the weapon as well. So whenever anyone is trying to access the data for any other person illegally, that is actually comes under the computer crime. So now there are so many different crimes, but if we suppose group them, then we can see that there are the hackings. The hacking is the one of the major part which is actually very, very much popular among those crimes. And then there are the other crimes as well, like denial of attack, virus disseminations, computer destructions, cyber terrorism, and cyber. There are so many nowadays, but these are the few of them. If suppose we just group them with how and where these are. So now, what is hacking? We are aware. I'm sure that we all are aware about that. Okay, that is actually a simple term when anybody can illegally try to compromise the data, CIA, confidentiality, integrity, or availability. They are going to compromise for anyone's data, personal data, or organization data. That is actually known as the hacking. Right now, I'm again pretty sure that most of us, we are aware about the different terminologies of the hackers. And normally we have 9 different types of hackers, but the 6 they are well known, acceptable, and they are in literature that they are considerable. So these hackers are known with the different colors of their hats. Like suppose we call them the white hat hacker, the gray hat hacker, red hat hacker, green hat hacker, blue hat hacker, and black hat hacker. So these are the different terminologies, and they are very important to understand. Say, for example, if we talk about the green hat hacker, so they are very newbie, and they are just learning in their span, and they are not able to bring any laws to any organization or any of the individual persons. When we talk about the blue hat hackers, they are those who are very dangerous, but they are not a regular sort of the hackers. They are those who are just trying to take their image. Say, for example, if suppose the two friends, they are good friends, and now they are going to be having a separation. So because now this can become a very dangerous, the point is that because they are well aware about their secrets already, or any employee who is working in any organization, and now for any of the reasons, say for example, that they are just going to fire for the employee, so then the employee can become a very evil for that organization, because that employee has all of the information already because he was a part of that organization. So that comes under the blue hat hacker. So when we go for the red hat hackers, that is actually the hackers who can use these hyper attacks to attack the what we can call the black hat hackers. And the black hat hackers are what they are actually the one which are actually creating a lot of the problems, and they are the actual hacker. They are the one they are becoming the reason for the loss. So if we see from these sort of the hackers, then we can understand that there are the few hackers. They are ethical hackers. We bring them under the category for the white hat hacker. And there are the gray hat hacker, where we are not aware about them, that their activities are going to be positive or their activities are going to be negative as well. So these are the different classifications of the types of the hackers. They are can be divided into the different groups based on their functionalities and also based on their knowledge level as well. So they are the one who are always active, and they are the one who are bringing a lot of the damages and the challenges to our society as well. So today we are focusing about society. So we need to understand that where we stand at this moment. So now we can see that what are the top 10 most valuable informations that is more important for the cyber criminals. So this is well known, and this is a truth that these attackers, they are very weak. They cannot come and compromise your data until and unless they need to know some of the basic information about your system and about your credentials. So now how they are supposed to get that? So they have the different mechanisms. Like suppose we can see on the right side that these are the top biggest cyber threats to the organizations, from which one is the phishing, malware, cyber attacks, and these things. So these are the methods, and these are the what methods they are using. So they are applying through the coming up through the spams, coming up through the emails, coming up through the what we can say the spam links, and there are so many different mechanisms they are applying, and then they are trying to get the information what they actually require, and then after that they can be able to compromise the machines. So now in the cybersecurity world, this is very important that the awareness of the computer usage. So we need to have a training, a proper training to know how the computers need to be used, specifically from the aspect of the security. So most of the time, our users, they are educated user. We consider them as an educated user from the perspective, different perspective. But when we link about the cybersecurity perspective, then all of the staff, all of the employees, all of the members, all of the individual members, everyone, they need the sort of the trainings. So they need to be aware that how they are supposed to use. So in different institutes, we have the different policies. Those policies are actually helping the cybersecurity. But then again, there is a huge gap. Now, for these few statistical slides, they will mention us that where we are living and what is the actually level of the danger. So now from here, if you see that this is the percentage which is compromised at least one time of successful attacks. So there are so many attacks which are almost always happening. So we will see the live attacks as well. Once we just discuss about these statistics, then we will go about the live attacks right at this moment and what is happening. So before that, we can see that within 1 year, when and where and on what countries, how many successful attacks are there. So if we see from the percentage point of view, you can find out the Colombia, you can find out the very advanced countries as well, like suppose China, Germany, USA. So those countries which are advanced, that doesn't mean that that is the guarantee that there are no successful attacks of the cybersecurity. So this is completely a common threat for entire globe, completely a common threat for the entire world as well. We need to, train our people, we need to train our people, and we need to learn that how we could be able to save our machines and our organizations and ourselves as well. So now from another perspective, we can see that how many organizations they are compromised with the successful attacks for the last years. So we can see that this ratio is increasing. If we compare from the 2014, it was 61%, and then it is reaching to the 86%. Though we are increasing day by day with the cutting edge technology, we are becoming advanced. But the same thing, at the same time, the hackers, they are also well aware, and those technologies are being used on the other side as well. So these are very, what we can call challenges for us that we need to see that how it could be addressed. And even especially if we focus for the future, then these challenges become even more while where the Bell Laboratories, they already tested for the conventional network, that the throughput data, they already tested 39 terabyte per second. And for the wireless chip, they already tested 37 GB per second. So we just assume after a year or two, once that data rate will be there, once that infrastructure will be there, so then at that time where we stand in perspective of the cyber attacks. So at that time, what the current mechanisms what we are using, maybe that will not be enough. No current IDS, no current IPS system, no current, like we can see at this stage, the AV system is almost now obsolete and it is not useful. So in the same way, we can see that what are their methods, how they get success, how they are getting the information from the user, and then they are going to attack them. So most of their ways they are coming up with the email link, they are coming with the direct install, they are coming up with the by downloading, by inviting, downloading for the some of the malwares, using the some of the what we can call the ransomware approaches. So a lot of the different approaches, and those approaches could be we could be able to stop them in case of if suppose our users are trained for that particular part. Right. So now if we just see that how these things is increasing in case you suppose we just compare the one attack, which is the ransomware attack, so we can be able to see that how much organizations they are victimized, okay, and how many organizations they are affected and they are paying. So this is only one data for the one attack, and if we just consider about the other attacks, then we will be aware that how many attacks and where we stand actually. So this is the need of the time. We need to be understanding about understanding about that, and we need to train ourselves and our employees, and then we need to see that how we could be able to save that. So now these are the statistical data, as what I mentioned, that we will be going for the live attacks as well. Probably I will not take much time, as mentioned, to cut it down. So within the 20 to 25 minutes will be done. So now these are the highlights. If we see for this much applications which are actually compromised, okay, and this is all of the data. So if we compare for the data, we can see that this is always on the higher end. It's not at the lower end. So if we just consider now in this current era, the cybersecurity is as much as complex as we can see how this figure is actually illustrated to us. So this is how we are in a very critical time where we are supposed to be very careful about so many things, and then we will be able to see that how we could be in that position to save our side. Now, in this perspective, if suppose we see that how the cybersecurity current attacks are there. For example, if we just go through for a moment, we can find out that in every new infection is every 3 seconds. After every 3 seconds, there is a new infection. And globally, we are looking that in every minute, there are several numbers of the instances are happening. And this is how this is a continuous practice. So probably rather to discuss from the slides, maybe I can take you to the live demo. That's more good. Okay, so here we go. Right. So we can go through with this live demo that can help us to understand. These demos are available from the different companies. Now we see from here this is the cybersecurity threat, which is the real-time map. Okay, and we can see this one, that this is what actually happened at this moment. For example, if we just try to make a space here, okay. So these are the attacks, what attacks are happening. We can see from the legends. This is the legend. These are the red color. This is showing the diamond. This is showing the attacks. And these are the yellow colors are showing the infections. Okay, so it is not necessary that all of the attacks are getting successful. So the most of the attempts are there, but they are not successful. And most of the attacks, they are getting the successful. And this is a live data, a current data. So now from here, we can see this is the means time, which is the Thursday, October, and 8:48:51. This is the local time here in Malaysia. And these are the attacks in case if suppose we can be able to identify which type of the attack. And then this is means what type of attack it is, means spam, or it is only what we can call the blank attack. Then it is any infection is there. And then what are the attack countries? Okay, so the target country and from where it is initiated, and what are the top locations which are under attack at this stage. So now this data is depend upon the attacks, how many attacks are being happen and how many attacks are successful. So the same live data we can be able to monitor on our dashboard, right? So this is how, if we just look for this, then we can understand that where we stand at this stage. So this is something which really need a lot of our attention. Now, another perspective, we can see that this is another data, live data, which is showing that how many attacks are being happening and on what is the severity level for them. So from here, we can see the few of them, they are very critical, medium, and high and low. And then on what locations the attacks are being happened. So if we just notice that most of the time, the attacks are on the advanced countries. So the literature suggests that more than the 80% of the people, the society, the community who are living in the USA, they are either compromise their data once or more than one time. So that is an alarming situation. That's a very critical situation. And we need to be aware about that. And we need to train our users. And we need to have the sophisticated mechanism and manner. So we need to think that either we are ready at this stage or not. And when we discuss about that now, the data rate will be coming up to the 39 terabyte. So you can see from the map, there is the India and Pakistan as well. So this is a live, all the time. So we don't know that when and where these attacks are being happened. So the same way, if we just go for the another perspective, so you can see that here, if we suppose go for the full screen. So maybe I can show you the legends here. Sorry for that. Yeah. So from here, this is the local time, and this is showing us the attacks. Okay, for today. Today attack means the last 24 hours. So how many number? This is a huge number of the attacks, but this is not means taking in consideration all of the attacks. So they are only considering the few types of the attack, and only for this you can see that how many attacks are being happen in one day, and the details are here, and we can see from here, from Brazil where it is, from Germany where it is, from Egypt where it is, and either they are successful or not. And the same way, what are the top 5 industries which are under attack? So we can see the financial for sure. This is the more interested towards the hackers. Then the services and consultancy, then the telecom industry, and then the manufacturing industries. So if we put the mouse cursor, then we will be able to see the further details about that as well. So in the same way, if suppose we go for the other attacks scenario, so again, we can be able to see that how many attacks this map is elaborating to us. So if we just keep it this way, so on this day, this number of the attacks, okay, and we can see for the previous months and previous hours and previous days for the attacks here. So this is the complete data, and how many attacks are there, and how many they are successful, and which countries are under attack, and which sectors are there, and what type of the attacks are here. So we could be able to find out the details. And pretty sure this is the live attacks, but this is pretty sure that we don't have the access to what we can call the actual data, because this is only the versions which are released for the public for the research purposes. So that is actually not at the same level. But if we just go for the real data, then these numbers are even more than this one. So now if we just see for a while, if suppose to this, which is the digital map, this digital map is only focusing for the DDoS attack. And this can show us that how many attacks are there, and we can be able to, this is a little bit very heavy website, so maybe we will not, sorry, we will not play anything. The link is given here and link is given in the presentation as well. You can be able to see later on. So you can see from here that these are the different, pattern of the attacks. Say, for example, if suppose this is the pattern, then between two countries, and if this is the pattern, then this is the DDoS attack, but within the same country. So if you just put the mouse cursor, rotate your mouse cursor, then you will be able to see the further all details that how long this attack was there, what was duration like for this 53 minutes, and how much volume of the traffic it was disturbed, and so many things. And also we can find out the further details even for the previous years, and even we can find out for the current years. And also we can be able to find out the data for the different countries as well, that how many attacks country-wise, and how many attacks month-wise and year-wise, and how many attacks as a global. So these all of the things, and then also these all of the informations are given here. So I'm not going to play anything from this one because it's a very heavy website, even though my machine is very powerful. But again, this will put us in a not a good situation. So this is how these are the actual scenarios where we are sitting. And if we are not aware about that, then this is another thing. Okay. But we need to be aware. Most of the time, most of the people's machines, they are compromised and people are not aware. Most of the machines, they already contain the bots, but people are not aware that what it is happening with them. Most of the time, even our cell phones, they are compromised, but we are not aware about that. So this is how, these things are very critical, and that really need to address them in a better way. And the most efficient way to address them, that is to train our users that they could be capable, that see that how these things could work. So now these are the slides we may skip because we already go through with the live demo. Now, these are the challenges for the cybersecurity. Okay. So what are these challenges that we need to adapting to the remote workforce nowadays, especially after COVID? And that become a very, challenging and very long. And then on top of that, we are going towards the emerging 5G applications and the blockchain and cryptographic attacks and the Internet of Things, IIoT, like what we can say, it was started with the one concept, but now we can find out everywhere in the smart cities. We can find out with the smart vehicles, Internet of Things. We can find out in Industry Revolution 5.0. We can find out in medical. So we can find out in every domain. So these are actually the challenges, as what we discussed, that this much number of volume of the attacks are there. And again, we are moving towards the from 5G to 6G. For wireless generation, from moving toward the 7th generation, and at the same time we are moving to the society 5.0, and at the same time we are moving now to the Industry Revolution 5.0. So we are increasing with the internet next version. We are increasing with the bandwidth. So these increase in the bandwidth and these things, they are the one side of the coin. The other side of the coin is that a lot of the different challenges are there. Okay, so we need to make ourselves ready. As an educator, as a researcher, we need to see that our graduates are they ready? Maybe our curriculum is ready for that. So these are the important points, and the current aspects that what we are using now for the cybersecurity, they couldn't be able to survive. The same as an example, what we discussed about the AV antivirus, that couldn't be work anymore. After the 1 or 2 years, we need to have autonomous solutions. We need to have the solutions they can detect, not only detect and identify, but they need to provide us the mitigation up to some certain level. Because with that bandwidth, we will not be able to survive. If suppose we will not be responding in a timely manner, right? So. The conclusion is that the cybersecurity has agreed to the next level. We are with the machine learning AI, so these technologies are being used by the hackers as well. So the conclusion now, are we ready to survive in the upcoming years? If we are not ready, not a problem. Still, we have a time. We need to have a plan. We need to make our workforce ready. We need to make our graduates ready. With the researchers, we need to think about in that direction, that how could we will be able to finish that one. So thank you very much. I tried to go a little bit speedy just because of to manage the things within the limited time, but it was loaded. Thank you very much once again.
Thank you very much, sir, for sharing the valuable information. To acknowledge the respected speaker, I would request Director UIIT Professor Dr. Yasir Hafiz to come over and present the shield and certificate. On behalf of Dr. Nurizuman, I would like to call Dr. Mariam to receive the shield and certificate.
Thank you very much also for sparing your precious time. Thank you once again.
Yeah, most welcome. Thank you. Thank you very much, Prof.
Now I would like to introduce respected speaker, Dr. Maimoona Humayun, who has joined us from Saudi Arabia. Dr. Maimoona is currently working as an assistant professor in the Department of Computer and Information Science at Jaffa University, Saudi Arabia. He is an active reviewer for a series of journals. Her research interests include global software development, requirement engineering, knowledge management, cybersecurity, and wireless sensor network. Now I would request Dr. Maimoona to please start the online session on blockchain for the Internet of Things.
Assalamu alaikum. I hope my screen is visible.
Yes, ma'am.
Thank you so much for providing me the opportunity to have a talk at this wonderful occasion. Today, I will talk about blockchain for IoT. The agenda of my presentation includes the definition of blockchain, IoT, the role of blockchain for IoT, the working of the blockchain, the various types of blockchain, the applications of blockchain for IoT, and finally, I will conclude my presentation by exploring the role of blockchain in IoT. So basically, blockchain is a system of recording information in a way that it makes it difficult to hack or to change. So the idea behind the use of blockchain is to make the IoT system more secure. So basically, what is the blockchain? It is defined as a chain of blocks that contain information. The technique is intended to timestamp digital document so that it is not possible to backdate them or tamper them. So if we want our document to be consistent, and if we want to avoid the duplication, then blockchain is the best solution. When we talk about the IoT, basically what is IoT? IoT means everything in the real world is connected or can be connected to each other with the help of sensor and actuator. It is actually the network of physical objects. These physical objects can be anything, which means anything in the real life, whether it is your car, whether it is your home or anything, you can connect it with the help of IoT. But there are some challenges of IoT. These challenges include data integrity, data sharing, authentication, access control, and privacy. Because we all know that the competition power of the IoT devices is limited. Therefore, it is easy to hack these devices. So the basic problem with these IoT devices is security. And to overcome this problem, blockchain is the best solution. When we combine blockchain and IoT, they both can benefit from each other. And this is called digital transformation. Like according to Gartner, they said that it's a sweet spot for digital transformation when we use blockchain for IoT purpose. Now the question is how actually blockchain works. So here in the diagram, you can see the steps. First, a transaction is requested. This can be any transaction, like for example, sending a money is a transaction which is initiated using a blockchain. Then this transaction is broadcasted to the blockchain network. After that, network validate the transaction using cryptography just to make it secure. Then the transaction is represented online as a block. And this block is added to the existing blockchain. And thus, in this way, finally, the transaction is complete. So now what's the benefit of using this whole scenario or the blockchain in IoT is that nobody can hack this system. Although it is possible, not impossible, but it's very difficult to hack the system. There will be no duplication in the record. Here is the structure of the blockchain. What actually is a block? A block contains a number of different transactions, and each block has its own hash, transaction details, nonce, and previous hash. And this block is added whenever the new block is created, it is added to the existing blockchain. How blockchain works, as you can see here in the diagram, when the transaction is required, a block is created for that transaction. This block is sent to the network of the blockchain, where this transaction is validated, that either it came from the valid user or the attacker. If it is from the valid user, then this block is added to the blockchain, and finally the transaction is completed. When we talk about the structure of the blockchain, it can be the centralized blockchain, decentralized blockchain, or distributed blockchain. All of them have their own pros and cons, as we can see here. In the centralized network, it has a single and easy point of failure and maintenance. But when we talk about the decentralized network, it has finite points of failure and maintenance. Similarly, when we talk about a distributed network, it has difficult point of failure and maintenance. As you can see here, that in distributed, all the peer nodes, they are connected to each other. So from the diagram, we can better understand that what is the difference between centralized, decentralized, and distributed. Like, for example, in centralized network, the network is highly unstable because everything is dependent on the centralized one. In decentralized, the network is already split into many. While in distributed network, this one has a stable network because every node is connected to all the other nodes. When we talk about the scalability means if you want to add something in the blockchain, centralized network have low scalability as compared to decentralized network, and distributed network have infinite scalability. There is an ease of development in this network because centralized network is easy to manage and maintain. But when we come to the decentralized network, it involves upfront cost in development. And same when we go to the distributed network, the upfront cost increase more. When we talk about the evolution of this network, centralized network is comparatively slow as compared to the decentralized network. And when it comes to the distributed network, tremendous evolution is visible in this network. When we talk about the type of blockchain, there are basically 4 types of blockchain: public blockchain, in which there is no central authority; hybrid blockchain, in which some part of the is controlled by the authority while the other part is accessible by everyone, single authority; and there is a consortium which is controlled by a group or an organization. So here are the examples. This is the example of public blockchain. Private blockchain, in which you can see that every node is private. Consortium blockchain, in which the blockchain is under the ownership of an organization or companies. Here again, I'll explain the working of blockchain with an example. First, a transaction is requested by the user of the blockchain. This transaction is represented as a block network. Once the transaction is validated, this block is added to the existing blockchain, and finally the block transaction is complete. Now the question is that how we are relating this blockchain with IoT? What are the benefits of IoT and blockchain? Blockchain builds trust in your IoT data because it makes your IoT data more secure. It relies on added security into your IoT data, gain greater flexibility, generate new efficiencies for your IoT data, and reduce the cost for IoT data by maintaining security. Here are some applications of blockchain. As you can see here, blockchain is used in business, industry, energy sector, supply chain, human resource management, data distribution, financial transactions, inventory management, integrity verification, healthcare, education, EHR. All these are some of the fields in which blockchain is playing a vital role. When we talk about the blockchain and IoT, there are some possible use cases of blockchain and IoT, like, for example, high data security. When we implement the concept of blockchain for IoT devices, definitely we can make the data sharing more secure. Real-time tracking mean anytime we can track the status of the transaction, that what is the current state of the transaction. Stronger cloud management. Blockchain is also used for managing the IoT data, which is stored in the cloud for future processing. For better automation process, definitely we can use blockchain. Identify for IoT devices, for better compliances, for data anonymity, for extra privacy, for better access control, for better authentication, for end-to-end visibility, for preventing from different kind of attacks like DDoS attacks, man-in-the-middle attacks. For all these purposes, we can use blockchain and IoT together. If we talk about some of the well-known companies which are using blockchain IoT, it include Helium, NetObjects, XH Security, Grid Plus, Autonomy, Retail Code, Hyper, Chronix, IOTA, and ArcTouch. These are some of the well-known companies which are using blockchain for IoT. When we combine blockchain with IoT, what actually is the benefit? As you can see here in the picture, IoT sensors, they are used to collect the data. This data which we collect from the IoT sensors, we store it somewhere like clouds or data center to use it in the future. And blockchain is used for the security of this data. As you can see that blockchain can play its role everywhere. And about IoT here, you can see that IoT mean Internet of Things, which mean everything can be connected. And as we can see in the picture, your car is connected, your refrigerator is connected, your screen is connected, your smartphone is connected. So all the data, everything we can connect using IoT. When we transmit this IoT data from one platform to another platform, we can take help from the blockchain to transmit this data securely. Here is blockchain and IoT. And basically in this picture, we have given the concept of smart city. Basically, as you know that many developed countries of the world, they are moving toward the idea of smart city. Smart city mean we are planning to make everything smart, like our energy system should be smart, our traffic system should be smart, our supplying food chain system should be smart, healthcare system should be smart. To make all these things smart, IoT and blockchain can play their role. Like for example, let's take the example of healthcare. The patients, they are having different wearable sensors attached to their body. The data of the patient is collected through IoT sensor, and this data is transmitted to the doctor through the cloud or 5G internet. Now, blockchain will play its role during the transmission and security of the data. So what we can conclude here, due to the shortage of time, I have a lot of the slides. So what I will conclude here that IoT-based application demands are changed with time. Now people want everything to be very smart and secure. For this, we need blockchain, which is essential for IoT. And during the process of data collection, data transmission, data storage, the movement of data, we need blockchain to secure to our IoT system. Security of IoT can be managed by blockchain. Similarly, efficiency of IoT devices can be enhanced through the use of blockchain. And if I conclude the whole presentation, I can say that blockchain is the right solution for IoT. Thank you very much, audience, for your patience. If you have any question, please welcome.
Thank you, ma'am, for the valuable information. To acknowledge the respected speaker, I would request Director UIIT, Professor Dr. Yasir Hafiz, please come over and present the shield and certificate. On behalf of Dr. Mamoona, I would like to call Ms. Sidra Tahir, Mr. Mohammad Azhar, and Mr. Mohammad Ehsan to receive the shield and certificate. Thank you, ma'am.
Thank you very much, Ms. Once again, thank you very much. workshop.
Welcome, sir.